Hi everyone! Welcome to Virtual EmberConf 2021. This is our second year doing a fully virtual conference, and we have a really fantastic event planned for everyone. If you haven't already, be sure to log in to the Ember Discord server and say hi. Discussion will be taking place there throughout the entire conference. We also have a companion app that you can access at meet.ps/EmberConf. There, you'll be able to find relevant materials for each of the talks, ask questions, upload photos from home, and send feedback in real time. While the opening keynote isn't scheduled until tomorrow, this year there was so much good content that we are diving in with a full afternoon of bonus pre-conference talks. We have some incredible speakers lined up. Let's get started.
Hey y'all, this is Melanie Sumner. I'm a disabled military veteran turned software engineer, and I'm delighted to speak with you all today. I wish I could be in person, but I'm looking forward to next year. I'm a member of the Framework Core team and the WAI ARIA working group, and I do these things as part of my job as a senior software engineer at Linting, where I work on digital accessibility products at scale. Since many of you will be familiar with my usual style of talk, I want to let you know that this talk is a bit different. In my other talks, I've spoken about what accessibility is and the things that we can do now. And if you're interested or new to accessibility and want to learn more, you can find my previous talks by visiting my speaking profile. But this talk is different because it's my vision for how I want the world to work and how I think we can get there. And just in case this is the first time you're hearing about accessibility, let's run through a few common terms, since over the next couple of days, you're likely to hear other people talking about accessibility too. When we say accessibility, we're specifically focused on making inclusive websites so people with disabilities can use what we create. You might also hear it referred to as A11Y, which is a shortened abbreviation. There are 11 letters between the A and Y in the word accessibility. I'll also refer to the Web Content Accessibility Guidelines, or WCAG for short, as a standard by which our applications are evaluated through the use of the success criteria they provide. And finally, assistive technology includes hardware or software that people with disabilities use to access the web or mobile devices. For example, a person who is blind might use a screen reader to browse and use websites on the internet through desktop browsers or mobile devices. So today, I'm going to share with you my vision, and that's a vision I'm calling continuous accessibility. Let's jump right in. I want you to take a deep breath and let yourself imagine. Imagine having greater confidence in the accessibility of your code. I want you to imagine more easily delivering accessible experiences at scale. And finally, I want you to imagine not being afraid of losing customers or facing expensive lawsuits due to accessibility blockers on your site. It's a pretty great feeling, isn't it? In software engineering today, we have continuous delivery, and we also have continuous integration. And these two things have drastically improved our lives. Unless, of course, you're the engineer working on bugs for these things, in which case you probably swear a lot, and I'm sorry, but we really appreciate your sacrifice. But now I want us to turn our thoughts to this new idea, continuous accessibility. How will we get there? How will we deliberately achieve this vision? As I like to say, we have to be on purpose. The well-established principles of continuous software engineering remind us to build quality in, to work in small batches, to let computers do the tedious stuff and humans can do the hard stuff, to always be improving, and that everyone is responsible for doing these things. In this talk, you will learn the essential points of strategy for continuous accessibility. So, what does that strategy look like? Well, this three-part strategy includes a plan for the code we already have, a plan for the code we'll have in the future, and a plan for how to measure our work, and we'll discuss why that is so important. But before we dive into that, I have some exciting news to share with you. I'm excited to share with you that we have already started on this continuous accessibility journey with the newest version of Ember template lint. As of the latest version, no longer in beta, we deliver template linting in such a way that it ensures our code has a path to become more accessible if it already exists, and that our future code will be more accessible by default. And that's really exciting to me. At Linting, we manually rolled out this feature to some of our apps already in production. We also took what we learned through manual implementation and built automated tools to do this work in the future. And we are also building trackers to ensure that the configurations remain correct over the lifetime of the code base. It's pretty cool. Any plans we make to improve accessibility in our products should include plans for the code we already have. We need to think about the age of our code base. We need to think about how we plan for library upgrades, because it's cool that we improve the accessibility on that popular UI add-on, but what does this mean for existing users? What does the upgrade path look like? We need to think about how we will deliver new features or developer tools. The code that already exists will not be able to consume the latest and greatest upgrades unless we've done this thoughtfully and purposefully. And it might take some trial and error. This is especially true for apps at scale. It can be tricky to update dependencies, especially when they include breaking changes. Depending on the size of your code base, taking in a new version of a dependency can mean extra developer coordination about which new features to use. And there are product and business priorities to consider. Features that we create for accessibility automation should make it simpler to deliver improved products and tooling to support accessibility as a facet of our craft. For the code we have now, we can wait for our users to report issues to us, but at the risk of losing customers. We can also rely on audits to tell us where the issues are. Ideally, we're automating our code linting and tests and periodically checking the code we already have. This gives us higher confidence that as technology progresses, our sites will still work as expected. Of course, there's a lot of improvement we can do in this area. But this approach allows automation to be our first line of defense, backed up by accessibility audits and user reports, because users will still let us know when they run into blockers. We need to plan for the code we will write in the future, or we will be much more likely to make the same mistakes of our past. Who knows what comes next? The way we wrote code yesterday is different from the way we'll write code tomorrow. What does our strategy need to include to prepare us for these unknown unknowns? Of course, we'll continue to follow the principles of continuous software engineering. One of these, letting computers perform repetitive tasks so people can solve hard problems, is what I want to focus on. This is something that we have and will continue to improve on. Let's take a look at the way automation and accessibility can help. Today, developers have access to automated testing through the Xcore library that can be integrated into our CI and CD mechanisms that are already used to test and deliver our code. We have a lot of options too. We can use Lighthouse, or Microsoft's Accessibility Insights, or the Ember A11y testing add-on, or even the Xcore library itself. For static analysis, of course, we can use ESLint, although it doesn't have any accessibility support, and we can also use Ember template lint. Developers can get linting feedback while they're writing their code. It also supports a plugin system that allows teams to define and use custom rules. Some rules have automatic fixes built right in, and running a fix flag will clean up all of the auto-fixable issues. Finally, it supports sharing configs across projects, so you can ensure that all of your teams are on the same page. Before version 3.0 of Ember template lint, the print pending flag gave us a way to roll out new rules. You could take a list of current errors, and we could basically make a ignore these errors list in the linter, but it relied entirely on teams to be proactive and treat that list as a burn down list, not a ignore permanently forever list. Of course, teams understood that we didn't really want to ignore these forever, but sometimes it's easy to forget something if it doesn't have a deadline. One approach was to turn a rule off entirely until all existing instances of that error were fixed. Of course, this led to a never-ending cycle of trying to turn a rule on, finding new bugs, fixing those bugs, trying to turn the rule on, and starting all over again. This is because by the time you fix the errors, new code would appear with those same errors. At scale, this is time-consuming and costly and can really disincentivize teams to keep up with best practices. So we had issues that could go into the lost void of forever or stuck in a never-ending cycle of almost ready to turn on, and we needed something different. Enter the to-do. In the latest versions of Ember template lint, we now have the to-do. Instead of only having the option to set a rule to warning or error, we can now instruct the linter to find all existing instances of a rule being broken and create a to-do for each. After a period of time, this to-do turns into the warning and then into an error. Let's look at this from a different perspective, from the perspective of the code we already have and the code we will create. When a new lint rule is released, existing code will have to-dos created and teams can plan to fix incrementally. For new code, it's linted as the code is written, so no to-dos have to be created and no extra planning is needed. How great is that? And this feature was intended to mirror the QUnit to-do feature, which gives better consistency for developers who already use that. You can try this out yourself today. Once you've installed the latest version of Ember template lint, you can run the linter to create to-dos with the update to-do flag. You can see the to-do count when you run the linter with the include to-do flag. And once an issue is fixed, you can automatically remove the to-do with the fix flag. It's so incredible that we can try this out now, and even more incredible that it's built into all new Ember apps by default. This kind of accessibility consideration is just one of the many reasons I enjoy using Ember. But let's now turn our attention to the third piece of this puzzle, the metrics, because we need a way to quantify our progress. Right now, there's no common shared standard for metrics in accessibility engineering, but my vision is to change that. Metrics play an essential part of our strategy because our goal is to demonstrate the business value of accessibility and make it a default part of our engineering practice. Just in case you haven't had to quite work with metrics just yet, let's review 4 of the commonly accepted key criteria of quality metrics. Wow, say that 5 times fast. Anyway, metrics must be meaningful. They must be connected to the goals and strategy of our organization. They must be controllable. If a metric is not under our control or our influence, it's not meaningful to report. Metrics should be easy to find, easy to identify, and visible to management. And metrics must be actionable. All metrics that we define must have an actionable outcome. But what do we mean by that when we say actionable outcome? Well, we can diagnose a problem, or improve a process, or set goals, or even observe trends that inform future work. But before I get into the specific metrics I think we should be measuring, I wanted to remind us, metrics themselves should never become the target. We won't reach our goal if we're gaming the system. Now, we all know that there are nearly infinite number of ways that anything can go wrong in our application. And that's not what I mean here when I say potential violation count. With potential violation count, I think this metric should be the baseline metric. We want to make an unknown problem a known problem, then solve for each. This baseline metric is the total number of individual ways an application could fail legal accessibility requirements. But how do we get that itemized number? A few things feed into that. We've got the web standards from WCAG, success criteria, known techniques, common failures. We have location-specific legal standards. For an example, in America, we have Section 508 and the Americans with Disabilities Act. And there are different standards for the European Union and Canada and different countries around the world. We also have failures identified by audit findings, because no matter how much spec anyone has written or how many laws anyone has written, developers will find a way to make an inaccessible interface. Of course, all of these potential violations represent a massive effort that has already been completed by user researchers. So how do you get this information in a practical way? We do this by making an itemized list. There will, of course, be some overlap, and we should document that, but this work is worth doing because it gives us the peace of mind that we really know the edges of this problem. We're turning an area of ambiguity into an area of clarity. We're making the unknown edges of this problem known, and that will give us confidence. And before you think, oh my gosh, Melanie, this is so much work, let me share with you the effort that's already begun to itemize potential failures. It's, of course, an open source project called the A11Y Automation Tracker, and it's just for developers. And it intends to compile each one of these itemized details. There's an overall details list, but there's also the ability to dive into each potential violation and see the status about how it can currently be tested, the possibilities for the future, and the relevant criteria with links to documentation. Of these potential failures, of these potential violations, my initial analysis has indicated that about half of them are either already automated or potentially automatable. But what about the other half? Well, this means that the rest still require manual testing. And I want to emphasize this again. You still need manual testers. If you're a small company, just remember that accessibility is a journey. Do what you can now and do more as you're able. If you're a large company, I want to encourage you to not outsource this work. In my experience, a few well-trained testers that share your company's values will be much more resource efficient than an entire army of outsourced testers. No matter what size company you are, though, I strongly encourage you to make manual testing an essential part of your accessibility strategy. Some of you who are already familiar with WCAG success criteria might be wondering, why not just use the WCAG success criteria? Well, here's why. They're generic. They cover generalities rather than specifics. For example, WCAG success criteria 1.3.1, information and relationships, is a single success criteria, but can relate to at least 25 or more different failure scenarios. When I write a linting rule, it needs to cover one specific failure, even if that failure can present in different kinds of syntax. By identifying the edges of a potential violation count, we can then determine several related metrics. Violations for which we can provide automated linting for static analysis. Violations for which we can provide automated testing for dynamic analysis. Violations that require developer author tests. And violations that require manual testing. There are also metrics that we can look at from the accessibility audits that we receive. What is the total bug count? What is the bug severity count? How severe of an impact do these bugs have for our users? Some are worse than others. What is the time to fix? How long does it take a team to resolve an issue? And violation frequency. How often is a particular violation occurring? So I've given us some essential metrics to track, but what sorts of things are we hoping to learn? What impact do we expect to have? We should expect at a minimum to see some trends as a result of the actions we take. We can expect, for example, to see an increase in the number of automated linting rules and tests, since we have a better way to identify specific potential violations. We can also expect to see a decrease in some things, a decrease in support requests, in accessibility issues in new code, and fewer issues in code that has the new automation applied. Our audit-related metrics could also inform process from a business and legal perspective, since they could be used to help quantify risk of legal action. When risk is quantified, we can then reduce that by taking specific steps to remedy the issues. And while this might be a business justification, the result is that our users have an improved experience. Improved monitoring also means that development teams know sooner if a product's digital accessibility conformance deteriorates at a rapid rate. It can also help us determine a threshold for new learning opportunities. If a high percentage of developers keep writing the same non-conformant code, we can produce materials that will help them on their learning journey. We can also use these trends to determine an app's overall accessibility health. We could even maybe put that in, what's that thing Ember is really good at? A dashboard? In addition to trend analysis, we can use the metrics we gather to inform future work, such as which possible violations currently require manual testing but could reasonably be automated. What violation is happening the most? Is there a tool we could create to make that problem go away? How could we make it faster for developers to fix the issues that seem to take a long time to resolve? There are additional metrics to be considered here, but I think the ones we've discussed give us a solid start to quantifying accessibility in our engineering practice, bringing us closer to continuous accessibility. I think there might be a new tool that our community could create. I have a vision of this being maybe available as an open source tool, something that anyone in the community could use to improve the measurements of accessibility in their code base. Of course, this slide is a little ugly and maybe a little bit on purpose. If you're offended by the design, please consider helping out in this dream and designing something better. With our metrics in hand, though, we could use this data to see clearly and quickly how we're doing. As we have looked at how to think about our code and what metrics to consider, I hope you've seen a path forward to the vision of continuous accessibility. I hope I have inspired you to create something new or to contribute to an effort already in progress. I hope I have empowered you to think about accessibility in your code in a new way. A lot of the strategy I have talked about today is of my own creation, but I'm part of a team and I stand on the shoulders of absolute giants. And I'd like to take a moment to recognize the contributions of others on the project. Robert Jackson, of course, among other things, maintains Ember template lint and directed the idea to add the to-do feature to Ember template lint. My colleague Steve Calvert drove the to-do implementation and designed the decay days feature. And internal teams at Linting have been enthusiastic early adopters. It's really allowed me to work out the kinks of our strategy to implement template linting at scale. I'm really grateful to every one of you. And of course, my husband Joseph. He supports me and my career, and he's the reason I can take time to speak with you today. As a research scientist, he has taught me to think more like a research scientist, and I am really grateful for that. In closing, I'd like to say this. This talk has been focused around providing a strategy to achieve continuous accessibility. But when a measure becomes a target, it ceases to be a good measure. It's so important, I'm saying it twice. Keep the end goal in mind. We're doing this work for real people. Accessibility is for everyone.
Hi everyone, I'm Brian. I'm a software engineer at Square, and today I'd like to tell you about how you can take advantage of linting with Ember in order to ship better code faster. I've worked on a variety of product teams over the years, and like many of you, I've shipped all sorts of cool features, and I've written and reviewed a lot of code. But during that time, I also noticed a lot that could be improved about the development process, such as developers oftentimes making the same mistakes again and again. And so I began to focus more on the infrastructure or platform side in order to tackle many of these recurring issues. Linting, which is a rule-based static code analysis tool, turned out to be a superpower for tackling many of these problems. Now, whenever you work on automation or related tooling, you need to be mindful of the situation turning out like this XKCD comic, where developing the automation can actually take as long as the original task. But my goal with this talk is to convince you that linting is something that will save you time, not cost you time, and that even writing your own lint rules is very approachable and something that you should add to your toolkit. So we're going to be looking at some real bugs caught with linting and other examples of how linting can benefit you, how Ember integrates with linting, and finally we'll dive into writing a lint rule of our own. So first let's look at this real bug that I've caught with linting. This is an Ember component which displays a list of milestones and whether or not they've all been completed. But there's a bug in this component such that the property here will always return false. See if you can spot the bug. Well, it turns out we were missing a return statement in this callback. It's a pretty common mistake to make given the different ways of writing functions in JavaScript. And now you may be thinking that TypeScript could help out here. TypeScript is definitely an incredible tool for catching mistakes and logic issues, and I definitely recommend using TypeScript alongside linting. But in this case, TypeScript alone would not have caught the issue. Technically, we're allowed to have an implicit return value of undefined in this callback, as that will simply be considered falsy. And so TypeScript will not report a type error with this code. Instead, this is more of a syntax pattern that often indicates a mistake, and this is something that we can use linting to detect. If you have the ESLint extension enabled in your IDE, you could have received immediate feedback about this issue from rules like array callback return, which would have noticed that the callback in this array function was either missing a return statement or should have been converted into the array for each function. Another lint rule called no unused expressions would have noticed that the expression here, milestone.completed, is useless the way it's written, and thus we're likely forgetting to do something with it. Let's look at some other benefits that come from linting. I really appreciate how linting can not only help to enforce best practices, but it can also teach us about them. In fact, when it comes to onboarding a new member to our team, it's really magic how the tooling can now do much of the work of teaching best practices for a given codebase or framework. In this code sample, I'm showing a simple Ember component that is not doing a great job of following Ember Octane best practices. First, we prefer to use Glimmer components over classic components in Ember Octane. And second, we prefer to use native JavaScript classes over classic classes, kind of going along with how Ember has been moving away from Ember-specific syntaxes that are no longer necessary. And third, there's a rule to help guide us away from using the tag name on the component, because Glimmer components no longer provide a wrapping element for that tag name. Linting is terrific for accessibility. Here I have an HTML image tag, and I'm actually forgetting a key attribute on it, which is the alt text attribute that's needed for screen readers to describe what this image depicts. So I'm trying to fix the issue here by adding some alt text, but it turns out that there's still an issue. In my codebase, I'm also using the no bare strings lint rule to ensure all of my strings are translated for different languages and countries, another aspect of accessibility. I'll likely need to use a translation helper to fix this. Linting can also help us with tightening security. We want anyone using triple curlies in their templates to be informed that they may be allowing unsafe HTML to be injected into their page. Now, as always, if someone has a legitimate reason for writing code like this, then they can always disable the lint rule on this particular line of code, ideally including a comment about why they need to disable the rule. Let's look at how Ember uses linting. ESLint is the core JavaScript linting framework, and really the great part about it is that it's extensible, and so we use it for our Ember linting plugin as well, which I'll talk about in a moment. There's a node linting plugin which can help us ensure we're avoiding deprecated or unsupported node APIs. There's a QUnit linting plugin which is new in Ember 3.26, and this one is great at detecting test assertions that may be written incorrectly or in a confusing fashion. There's Ember template lint, which I'll talk about in a moment. And there's also Prettier, which is new in Ember 3.24 and can really help us to auto-fix all of our code formatting and simply eliminate the bike shedding and knitting that comes from differing code style preferences. So let's dive into ESLint plugin Ember. It's the JavaScript linting plugin for Ember, which is pretty mature at this point. It has over 60 recommended lint rules. The latest version comes with Ember Octane linting enabled by default, and this is really powerful because we can use linting alongside code mods to help us modernize existing applications and kind of guide them towards Ember Octane paradigms. As we saw earlier, there are rules for things like encouraging Glimmer components, native classes, track properties, and we've also had a focus on robustness in recent versions of this plugin. We always want to minimize false positives so that developers can trust the linter. And finally, we've updated our rules to support all the exciting new JavaScript syntaxes that have come out in recent years. Ember template lint is Ember's custom linter for handlebars templates. This one also has a sizable number of lint rules, and the latest release also comes with Ember Octane linting enabled by default. There's also a neat new feature for setting due dates on linting violations, something that can be useful when you have hundreds of violations to address. And finally, there's a new feature for linting arbitrary file types, including plain HTML files. So now let's walk through writing our own lint rule. Because if you frequently see developers making the same mistakes, you should consider whether you can write a lint rule to solve the problem once and for all and help guide developers in the right direction. Don't just fix it once, fix it for the long term. Let's implement a simplified version of the Ember no-get lint rule. This is a rule that Ember uses to encourage developers to migrate from the older Ember object get function to the new JavaScript ES5 getters, which are a cleaner, more standardized way for accessing properties. This is going along with how Ember wants to reduce its weirdware and also reduce its learning curve. I like to follow test-driven development, so when I write a lint rule, I'll typically start out by writing the test cases. First, we can write out some disallowed test cases, things that should be flagged or caught by the lint rule. And here I have the basic form of this.get with my property name. Then we'll also write out some allowed test cases, some variations that we do not want to flag because they're using unrelated functions, unrelated objects, or they're simply too complex for us to handle right now. All right, so now let's focus in on this disallowed code sample. I'm going to paste this into a website like astexplorer.net to generate the abstract syntax tree. And now let's walk through how this abstract syntax tree on the right corresponds to this single line of code. So first we have a call expression, which is like a function call. Inside that we have a member expression, this.get. On the left side of the member expression we have a this expression. And on the right side we have an identifier named get, which is the function name. Finally, we have a string literal arguments inside the function call. Keeping this abstract syntax tree in mind, let's write the actual implementation for this lint rule. ESLint provides us a convenient framework for visiting nodes of different types. And so on the left here, I have a visitor function for visiting every call expression or function call in a JavaScript file. Inside the visitor function, we'll use an if statement to check for the particular tree structure that we're looking for, and if we find it, we can at that point flag a linting violation. So inside this if statement, I'm first going to check for a member expression as we saw before. On the left side or the object side of that member expression, I'm going to check for a this expression. And on the right side or the property side, I'm going to check for an identifier. Identifier named get. And then a single function call argument, which is of type literal, and that is a string that does not include a period, because for now we're ignoring nested property paths. So if the linter gets this far, then we found the particular structure that we're looking for, and we can report a violation with an error message indicating the problem and potentially suggesting a fix. It's not pictured here, but we could also at this point provide an autofixer function to automatically correct the code, something that is incredibly useful when we have hundreds or thousands of violations. And that's it. It really wasn't that scary writing our own lint rule. In fact, we could largely fit the core functionality in a dozen lines of code on a single slide. Now we can decide where to publish the new lint rule. If this rule was for some reason specific to our own code base, application, or company, we could create our own linting plugin for it. But ideally, for a generic lint rule like the one we've just written, we can contribute this back to an open source linting project. That way we can all clear our minds of this issue for good and get back to shipping our application. So now it's your turn to pick a common nit or other mistake that keeps coming back to haunt your team and to try writing a lint rule to address it. You'll also, of course, want to make sure your IDE is highlighting and auto-fixing linting violations for you. And you'll want to consider researching and installing any other relevant linting plugins for your codebase. I've included a handful of my favorite linters for you to check out here, but there are still hundreds or thousands more to choose from. Thank you and happy linting.
Welcome to my talk on handling images on the web. I'm Marco Ottawitte, founder of Simple Apps. We're a digital product development consultancy working with international clients, helping them build web apps for all kinds of purposes, from banks to train ticket sales portals and online learning platforms and beyond. And whatever we and everybody else does on the web, images play an important role in that. Ever since the first image was uploaded in 1992, which allegedly was this picture. It shows the band Les Horribles Sernettes, which was formed by 4 CERN employees. And like with everything else relating to the early internet, the first image also comes from CERN, of course, which is where the web itself was invented back in the day. You will recognize the band's initials are LHC, Of course, these happen to also be the initials of the Large Hadron Collider, which is that huge machine that the CERN uses to research some fundamental aspects of physics, which is likely a very interesting topic and also something I have absolutely no knowledge of, and is not what I'm going to talk about here. So since that first image was put on the web, nothing really has changed fundamentally in the way we use images on the web. We use an image tag, set its source attribute, and that shows the reference image on the website. So that seems easy enough. But with the change and progress the web has seen since 1992, the possibilities in terms of what we can do with images on the web have changed and evolved as well. And so have user expectations. To cater to those, a bunch of extensions have been added to and around that simple image element. So these days, the highly optimized equivalent of rendering the same image on a website might look something like this. 15 lines of HTML with a bunch of stuff in them that can seem pretty overwhelming perhaps. And there's even an entirely new kind of image format that can go right in the DOM, which is SVG. SVGs can even be styled with CSS and be modified at runtime so that the content of the images itself can change. So images have changed from something relatively simple into a complex topic that sometimes can be hard to navigate and make sense of. And while we all spend quite a bit of time and effort optimizing the JavaScript that goes into our applications, images often do not receive that same level of attention. Although they make up around 60% of the total number of bytes that a user needs to load for the average website or web app. And decisions we make around images have a real impact on our users' experiences. So in this talk, I want to look at how images even end up in our applications, what decisions we can make when adding images to our apps, what the consequences of these decisions are, and what best practices are to be aware of. And I want to do that by looking at 3 typical scenarios for images. And usually each image you will be adding to your app will fall into one of those. The first scenario is images that are used as an essential part of the UI, which are mostly icons, like in this example, which is the main navigation menu from the LinkedIn app. Then there are static images that, like in this example, from a LinkedIn landing page. Other examples would be images used on blog posts or so on. This kind of image would typically just make a site nicer visually or support other data or content, but not really be essential itself. And finally, there's images used as part of the data an app deals with, like in this example, which is a post on the LinkedIn feed that also includes an image. These kinds of images would usually be part of some data loaded from an API and therefore only be discovered at runtime. So let's look at each one of these in more detail, starting with the first category, images used as an essential part of the UI. These are typically icons, as I said, or some kinds of status indicators. And icons are used everywhere on websites and web apps alike. They add additional meaning to otherwise purely textual UI elements, or sometimes even the only way we assign meaning to elements, like with a classic hamburger menu icon. So what are the characteristics of such images? Most sites and apps would have lots of icons. Typically, every functional element in an app would have some sort of icon associated to it. Icons must also be displayed immediately. We would certainly not want to lazy load our icons so that the UI first renders without them, and they would only pop in as the images get loaded from the server. Without the icons, the app would appear broken, and some functionality might even be completely inaccessible. Icons also adapt to application state, in this case signaling that there's a connection request we haven't seen. So what options do we have to add icons to our apps? We could add the icon image via CSS as a background image. This is the easiest solution probably, but doing this means the image will be loaded only once the tag has been rendered and the browser parses the respective style rules. So it pops in with a delay only. Most of the time, the delay might not even be noticeable, but connections aren't always reliable and fast, and sometimes loading the image might even fail completely, so the UI remains incomplete indefinitely. And we can also not style these images to reflect changes in the app state. So we need additional classes with additional image to reflect additional states. So how can we improve this? We could include the image right in the CSS as a base64 encoded string, so the image will show right away and not pop in after a delay. Again, for every additional state, we need an additional class in the CSS, each with its own additional image. But in this case, each additional image for each additional state isn't only an additional background image style with a separate URL, but each of these images ends up in our CSS in its entirety, which of course grows the CSS substantially over time. The problem is CSS is a render blocking resource, meaning that before the browser can render our web app, it needs to load and parse all of our app's CSS. So the larger that CSS becomes, the longer the time it takes for your app to render will be. So you'd really want to keep the CSS as small as possible, which is a goal that adding a whole bunch of images as base64 encoded strings, even if each individual image is relatively small, doesn't make easier to achieve. So what other options do we have? We could use an icon font like Font Awesome. With this approach, you would load a custom font file and then use special elements in the HTML that use that font, and instead of normal characters, show icons that are embedded in the font. This approach suffers from a similar problem like we saw before with specifying image URLs in CSS though. Until the font is loaded, nothing can be rendered as the browser does not know the font natively, and the icon only pops in once the font has been loaded. Also, we cannot easily reflect changes in the application state via changes to the icon. We need a separate icon for every single state, and in this example, we'd like to have to roll our own icon font even, so we can have icons for all of the application states we'd want to reflect in the UI. Finally, icon fonts are also bad for accessibility, as screen readers will treat these icons as text since that's what they are, which of course can make it much harder for some people to use our sites and apps. So are there only bad options then? Luckily the answer is no, because we still have SVG. Since SVG can appear right in the DOM and we can simply put the graphic right where we want the icon to show, the icon displays immediately with the rest of the UI with no delay. Also, SVG's vector format suits most icons well, since the shapes we're typically using for them are relatively simple and cater well to a vector format. So that means we'd usually end up with relatively small SVGs. We can also style SVGs with CSS, and we can even make the SVG itself dynamic and show or hide elements depending on the application state. So in this case, we can simply put the number of pending contact requests that we can only know at runtime right in the SVG and thus the graphic itself. However, as great as all this is, there's one downside to be aware of. Any new icon we're adding right in the template grows the template and thus our JavaScript bundle. And just like we don't necessarily want to grow our CSS as that's render blocking, the same applies to JavaScript. In fact, in the case of JavaScript, it's even a bit worse because JavaScript is parser blocking even. What that means is that when the browser receives an HTML document and starts parsing that, as soon as it encounters a script tag, it will block, load the script, execute it, before it can even continue parsing the HTML. The reason for that being that the script could potentially modify the HTML. Also, our JavaScript, of course, contains the app we're building. So everything that makes loading, parsing, and executing the JavaScript slower delays the startup of our app. So we wouldn't want to lightheartedly grow it with a bunch of SVGs. In the worst case, we could end up in a situation like this. This is a tree map visualization showing how the total number of bytes in the JavaScript bundle of an app is distributed among the individual modules. The app in total is roughly 3.2 megabytes of JavaScript pre-gzip, but 83% of that are made up by SVGs. This can, of course, be completely reasonable if these SVGs are somehow essential to your app, but it's also kind of easy to end up with a bundle like this by accident, when you're not paying close attention as you're adding SVGs into your templates, and just copy-paste what the designer gives you, for example. So it's good to have a bit of tooling in place to prevent that. One thing we can do is lint our templates using Ember template lint. We could add a rule that prevents SVGs beyond a particular size from being added to templates, or one that enforces a maximum total size of all SVGs embedded into all templates. However, strict rules like that don't always work very well. What's more important is awareness of the consequences of what we're doing, which starts with surfacing data that would otherwise not be easily accessible. A great tool for that is Ember asset sizes action, which is a GitHub action that the Ember learning team uses to build the Ember website. What it does is it compares asset sizes of production build of the master branch with the asset sizes of production build of a feature branch and posts the diff as a comment on the respective pull request. So with something like this, it's easy to see when you're accidentally embedding a huge SVG into a template and adding a small button with an icon ends up growing your JavaScript bundle by 50K, for example. That is something you will most likely miss in a review because nobody's going to look at an SVG in a template line by line and check how big it is. It's also kind of hard to even know how much a particular SVG would grow your JavaScript bundle, even if you did look at it line by line. So I would strongly recommend everyone using something like this. To summarize the topic of icons, let's look at all of the presented options we have for adding icons into our apps at once. We can use image URLs in CSS, we can use images as base64 strings in CSS, we can use icon fonts, and we can put SVG right in the DOM. Icons added as base64 in CSS or SVG in the DOM will display immediately with the rest of the UI. They do add some extra weight to our CSS and JavaScript, though where using image URLs in CSS or icon fonts do not really add any relevant weight. The only approach that allows us to freely adapt icons to our application state is using SVG, which we can modify entirely dynamically. So typically, using SVG is going to be the go-to choice here. But you want to make sure you have proper tooling in place to prevent accidentally growing your JavaScript bundle disproportionately, as explained before. So leaving icons and indicators behind us now, let's look at the next kind of image we're typically dealing with, which is static images. That includes photos or illustrations that make apps more appealing visually or support other content like text, but aren't really necessary to enable functionality or so. Most often those would be used on sites rather than apps, of course, where there's little functionality anyway. For example, landing pages like this one also from Linting. So let's look at this kind of image in a bit more detail. First of all, there's usually relatively few of these, certainly fewer than the number of icons you'd typically be using. But they are big in terms of visual size and often also in terms of number of bytes. They are also typically not really essential for the site or app to make sense or be functional, as discussed before. Even in the case of some sort of visualization in a blog post, the image would mainly support the text but not render the text useless while absent. So that means you wouldn't want to assign a lot of priority to displaying this kind of image as soon as possible, and you would almost never be willing to pay a price for them in terms of growing your CSS or JavaScript as you would be for icons, as we saw before. Also, these images would typically not adapt to application state but remain static, of course. So how do we add these kinds of images to our apps. We just use an image tag. Of course, when doing that, we would want to apply all of the optimization techniques we have at our disposal. We want to lazily load the images only when they scroll into the viewport. Or actually what the browser will do is it will load it slightly before that happens. So ideally loading the image has already completed when it actually enters the viewport. We want to load the smallest image possible for the current viewport to avoid loading unnecessary bytes. We can use the image tag sourceset and sizes attributes that allow us to specify different sources for different media queries for that. And that way we load the smallest image possible with the least number of bytes for the respective viewport size of the user. We'll also want to decode the image asynchronously so that that work can be moved off of the main thread and doesn't affect other things running there like our application's JavaScript. We'd also want to show a placeholder for the image that is injected right in the DOM as a base64 encoded string, and that will be shown while the actual image loads. Typically, you'd be using a very low resolution blurred version of the real image here that would only have a very small file size and thus be possible to be encoded in a relatively short base64 string so that it adds minimal additional weight to the HTML or the template that generates that HTML. And when loading of the image completes, the image will basically be put above the background and hide it. Last, we want to explicitly define the image's dimensions so that the browser reserves the space for the image element while the actual image is still loading and doesn't relay out the entire page when the image finishes loading. And doing all that, we get a pretty good loading experience for the image with minimal impact on the performance characteristics of the rest of the site or app. In this case, you see we're using a JPEG for the image. And I want to take a few minutes talking about image encodings here, since what encoding you use for an image will also have a substantial effect on its size and thus its impact on loading performance. Most of the time when talking about encodings, we're really only talking about two different ones. There's PNG, which is a lossless encoding that supports transparency, and it's typically good for things like logos, diagrams, and similar images with relatively little detail, but it results in huge files for photos as it's lossless. And then there's JPEG, which is lossy and does not support transparency, but works well for images with lots of detail, particularly photos. There is another one, though, that's still relatively new, which is WebP. It was originally designed by Google and combines the best of PNG and JPEG. It supports lossless as well as lossy encoding. It supports transparency and therefore works well for low detail graphics like logos, diagrams and so on, as well as for photos. However, there's one tiny drawback. While WebP is relatively well supported in modern browsers, and the lack of support in IE 11 is likely not a huge problem for anyone anymore, the problem now is Safari only supports it on macOS Big Sur and the latest iOS, which probably for the next 1 or 2 years isn't going to be good enough for most of us. There is a fallback mechanism, however, in the form of the picture tag. What that tag does is it allows you to list a bunch of sources and the browser will choose the best source and use that instead of what's in the source attribute of the wrap image tag. In this example, all browsers that support WebP will choose that source, and all the ones that don't support it will just use the JPEG from the image tag source attribute as a fallback. And you can also combine this with media queries on the sources and use it as a replacement essentially for the source set and sizes attributes on the image tag. So with this fallback mechanism available, you can really make WebP your standard image format of choice as it results in significantly smaller file sizes. This example shows a photo from our website where we needed a transparent background, which results in a pretty huge file size with PNG and only around 1/10 of that with WebP. Of course, this is an extreme example, and savings in less extreme scenarios won't typically be as big, but a rough percentage to keep in mind is about a 30% reduction in file sizes across the board, which is still pretty substantial. So to summarize what I said for static images, you'll pretty much always want to use WebP with the picture element to allow for specifying a fallback for older versions of Safari. You'll want to load differently sized images for differently sized viewports, so you don't end up loading huge photos on mobile devices, for example, where an image half the size or less would be sufficient. You'll also want to lazy load images, since not using bandwidth for loading images outside of the viewport means you have more bandwidth and resources available for those that are inside of the viewport. You'll want to asynchronously decode images so that that work is done off of the main thread and doesn't compete for resources with higher priority tasks like running your app's JavaScript. You'll want to show a placeholder that can display immediately while the actual image is loading. And you'll want to explicitly specify the image's dimensions on the image tag in order to prevent a layout shift on the page once the image loads. And doing all that, you get a pretty decent user experience with minimal impact on the performance of the rest of your site or app. So leaving static images behind now, let's look at the third and last scenario, which is images that are used as data. And by data, I mean something that is dynamic and that we get from some sort of API usually. This example shows the LinkedIn feed for the Simple Apps page. All posts are pieces of data, and the images that are shown there are attributes in that data. So what are the characteristics of these kinds of images? Well, the main characteristic is really that these images are only discovered at runtime, since we get them from an API. Regarding most other aspects, they are similar to static images, really. You're dealing with similar image sizes. You wouldn't usually want to change them in any way to reflect changes in the application state. And most of the time, these images aren't really critical resources where the UI would remain in some kind of invalid state until the images have loaded. So looking at the example of the LinkedIn feed, again, a typical way of implementing a feed like this looks something like this. We're loading post resources, and in the response receive a number of posts with attributes like title, text, and pictures. We'll then render the post in a component which could look something like this. And what this results in is relatively bad loading experience for the user though, because the browser can only start loading the image after we render the image tag with a source attribute pointing to the image. And while the image is loading, nothing can be shown, and since we don't even know the image's dimensions when rendering the image tag, we can also not set its width and height attributes, so the browser can also not reserve space for the element until the image is eventually loaded. That means displaying such a post will look something like this. First we see the post without the image, and as soon as the image is loaded, it pops in and triggers a relayout of all subsequent elements, shifting them down visually. Which is not particularly nice, of course, especially for a chronological feed where items are ordered vertically, and layout shifts make it very hard for the user to keep track of where they even are. This can relatively easily be improved, however. So what if the API response didn't only include the image's URL, but also additional information? What if we included everything that we need to apply the optimization techniques we saw earlier for static images, differently sized images for different viewport sizes, which are WebP images, a fallback JPEG, a placeholder to show while the image is loading, as well as the image's dimensions. Having these pieces of information, we can use them in the component that renders the post, using the same techniques we saw when talking about static images earlier. The picture element with different sources for differently sized viewports, a fallback JPEG source for older Safari versions, setting the image's dimensions explicitly, as well as enabling async encoding off of the main thread, lazy loading of images that are maybe further down the feed and thus outside of the viewport anyway, as well as a blurry placeholder to show while the image loads. Doing that, we get the same nice loading experience we saw before for the static image, which is obviously a huge improvement. One other thing we could be doing that goes even a step further is we could preload the image in the respective routes model method. In this example, we are first loading the post records and then preload all of the post's images before returning the model. In that way, we remain in Ember's loading state until the records as well as the images have loaded. Of course, it's questionable whether we'd be willing to delay rendering anything until all images have loaded, and in most cases we likely wouldn't. But there are cases where the images are such a critical piece of data that we might be willing to do this. Imagine what you're building is some kind of event registration app that uses QR codes for registration confirmations. It might well be reasonable to remain in the loading state for that route until the QR code has loaded, instead of rendering the route template earlier, but then the QR code would only load with a bit of a delay, leaving the UI in sort of an essentially useless state, since the QR code is the one essential piece of data here. So to summarize, for images used as data loaded from an API, we want to make sure to include additional information about the image beyond only its URL. At least that is the dimensions of the image, so we can explicitly set width and height for the image, so that the browser can reserve space for the element while the actual image is still loading, and thus prevent a layout shift once that finishes. Ideally, we'd also have separate URLs for differently sized versions of the same image, so we can load the smallest image possible for the user's device. We could also include a blurry placeholder to make the experience even nicer. Of course, the simpler alternative to that is to just use a generic placeholder for all images that we could define in our CSS, for example. And if the images are really a critical piece of data for the app, there's even the possibility of loading them in the Ember routing layer. This is of course not something I generally advise to do, but good to keep in mind as an option for special situations. So looking at these kinds of different images we're typically dealing with, we saw there's a lot of aspects to consider. And there's even a whole bunch of things I haven't really touched on in this talk. HTTP caching, service worker caching and preloading, CDNs and specialized image CDNs, animations and moving images, handling user uploaded images on the server, encoding optimized versions, calculating blurry placeholders, and much more. So what started with a simple image tag that was used to put a photo of Les Horribles Cernet as the first image on the web has developed into a pretty complex topic, and a topic that would deserve more attention than it often gets. And also a topic where doing things right or wrong can have significant impact on our users' experiences. And thus being aware of the relevant aspects to consider and possibilities we have to choose from in different scenarios, as well as the limitations and consequences, can prevent us from running into bad surprises when dealing with images. And that's all I have. Thank you.
Hi, my name is Caitlin, and I use she, her pronouns. I'm based out of Minneapolis, Minnesota, and I'm a senior engineer at CrowdStrike. My team at CrowdStrike has a really supportive culture that I think starts from our interview process. We've been able to scale up our team pretty quickly, so it has worked well for us. When I started 3 years ago, we had 10 front-end engineers, and since then we've hired 60. So, among other things, that means I've spent a lot of time in technical interviews. And by no means am I an expert on this, by no means is CrowdStrike's process perfect. But I think that it's important for us to talk about what makes technical interviews good, because there aren't a lot of resources out there, even though it's a pretty ubiquitous part of hiring in an engineering role. It's really hard to get better at something if you don't know what better looks like. So I'm going to spend the next 30 minutes telling you about things that I've learned from my own experience about how to make interviews more welcoming, more inclusive, and more useful. And the main point of this talk is be kind to people. It's really that easy, and it's also really that difficult. So what does that look like? Well, the first thing that we can do to make our interviews better is to plan for them. And this is going to look a little bit different everywhere based on who's involved in the hiring process, how much information you have beforehand, what roles you're hiring for, all of that. But let me tell you about what it looks like for me at CrowdStrike. So I work on a team that's distributed. We're across many time zones and many countries. So that means that I don't always have a lot of time to prepare with the other person I'm going to be conducting an interview with. And we're hiring at a pretty dramatic pace. I think we have 9 engineering managers who are hiring front-end candidates right now. So that also means that I don't always know what role or what team a candidate might be placed in. So it's not ideal, but there are still things I can do to plan ahead from that. One thing CrowdStrike has done is we have a set list of interview questions that we work from. And that's really helpful to keep interviews more consistent from interviewer to interviewer. We also have a rubric for those questions, which makes it easier to train up new folks on how to conduct interviews. And so what I will do is I'll work from that list of questions. I'll pick some that help me to establish a pretty broad baseline understanding of somebody's skills as an engineer. And then once I have a sense of where their passions lie or what they're really strong at, I'll dig more in those areas to try and figure out a little bit about who they are and how they think. And for you, this might look completely different. Maybe for you, what this looks like is sitting down with the hiring manager and with your team and figuring out, okay, what are we really hoping to get out of hiring for this position? And you might be talking about what skills you're hoping to bring into the team. You might be talking about where you think the team is already really strong and has the capacity to do some mentoring. You might be looking at notes from phone screenings or looking at even internal resources about different engineering levels. Just trying to get all that information together so you know what you want. Once you know what you want, then we have to think about how do we evaluate that. And it's a little harder than it sounds. One thing that it's easy to pick on in technical interviews is whiteboarding, which I know everyone hates. Well, not everyone. I'm sure there are people who have figured out how to do it well. I have not. And if you try to ask me a whiteboarding question during an interview, what you will learn is that I'm really bad at whiteboarding. You won't learn much else. So to put this another way, if you try to make ramen in the coffee pot, you shouldn't blame the coffee pot when it doesn't go well. One thing that has been helpful for me in trying to reframe my thinking about this has been to imagine that the candidate is already on my team and I'm trying to decide whether or not to work with them on a particular project. And that just helps me refocus a little bit and get a little bit more creative about how I start to look for some of these things to be demonstrated in my interviews. And I want to be really clear here that I'm not saying that you should plan out the entire interview and then just do that and not make any kind of allowance for what the candidate is like. You absolutely should adjust your interview to the candidate. But if you have a plan ahead of time, that gives you something to work with. And also, you should know if your plan is based on any sort of assumptions about the candidate's level of skill, people aren't always great at assessing themselves against your company's internal set of engineering levels. So if you have any assumptions about their skill level, it's good to validate those right away before you dive into some super complicated questions that might just put a complete pause on the interview with someone who's not well prepared. All right, so we planned for our interview, we've got a candidate in front of us. Now what? I think the next thing we want to focus on is making sure that the candidate feels welcome, feels like they can relax, and that they leave the interview feeling good. And there are a couple different reasons for this. Candidates are almost always nervous in interviews, and those nerves can become a huge blocker to figuring out what they're actually like in real life. So anything we can do to break through nerves and find out what a candidate's real self is like, that's time well spent. And in terms of how the candidate feels at the end of the interview, I've been to technical interviews before where I just feel crushed when I leave. And that's bad for a couple reasons. There's the very human, I don't like making people feel bad level. But there's also a business aspect to this, because people remember the way we make them feel about themselves. And they remember that when they're deciding later on which company they want to work for. So if you can start to demonstrate your team's culture and your team's values from the interview process, you're giving that candidate better information to work with. And hopefully you're making it more likely that they will want to accept your company's offer and come work with you. All right, so all of that said, what are some things we can do to make people feel welcome? The first thing is just make it a conversation as much as possible. I think just making some small talk, being really human with the candidate, helps them to know that you are thinking about them as a human too. One side note on this, nervous candidates aren't always great at small talk, so if that falls flat, don't blame them for that, but at least give them the chance. And then the other thing is just to be really mindful of what you are doing to create a welcoming atmosphere. And what I mean by that is paying attention to things like your tone of voice, your facial expressions, your body language. Maybe think back to some interviews you've been in the past where you haven't felt super comfortable, and ask yourself if there was anything that the interviewer did or didn't do that changed how you felt. And it's okay to not have a super warm personal style. It's totally okay to be very direct about this and just say to the candidate, I know our interviews can be nerve-wracking, and I want you to feel as comfortable as possible. And I'm also not trying to say here that you have to be Chris Traeger, who is literally high-fiving candidates and telling them that they are beautiful, charismatic, intelligent superheroes. What I am saying is that you should try not to be Ron Swanson, who's sitting there with his eyes narrowed and his arms crossed and literally pointing at the door. Try to find a middle ground between the two. The other thing that's a really great tool for us in helping candidates to relax is just telling them what to expect. As human beings, we love knowing what to expect, and we don't always love it while the explanation is happening, but later on, when something happens and we expected it, oh, it feels so good. So one thing that I do here is I try and tell the candidates right away, in this interview, it is okay to say, I don't know, or to say, I'm not sure, but here's my best guess. I think that helps set the tone for the interview, and I also really genuinely want them to do that, but I know I can't expect them to do that unless I tell them explicitly, because not every interview is like that. And the flip side of this is you should also tell candidates if there's anything they should expect not to happen. So to pick on whiteboarding again for a second, we don't do any whiteboarding or live coding as a part of our technical interview at CrowdStrike. And I try and make sure everybody knows that before we launch into the interview part of the interview. And you would be surprised how many people just visibly relax when you tell them, hey, you're not gonna have to do this. You can stop worrying about it. And that's exactly what we're trying to do, is to get them to be more like their normal selves. All right, so once we've got our candidates to relax a little bit, the next thing that's a really useful tool for us is how we engage with those candidates during the interview process itself. And what we really want to do here is get beyond those nerves and figure out what a candidate knows and perhaps more importantly, how they think, what they're going to be like to actually work with. So the way that I like to do this is with some interactive coaching. And I've got an example question for us here, so we can talk about some different strategies that we might use for this, depending on which candidate we're interviewing and how they respond to our questions. So the example that we're going to be using here is that we have an interactive table that we're adding to our page, and we want to know how we can make that table accessible. So for a candidate who's less experienced, or just a candidate who's really nervous and kind of getting stuck, one thing that we can do to follow up on this question is just to make the problem area smaller and more specific. So in this case, I might say, hey, what about a candidate, or what about a user who isn't using a screen reader, but they also still have some visual impairments? What can we do to make our page better for that user? And what I'm doing here is also trying to make the question itself a little bit less difficult, because a candidate who has no accessibility experience can still find some things to engage with there. And a candidate who has more experience can show me that still. But it lets us keep having a conversation so that I can keep learning about what the candidate's like, rather than us just sitting there and them feeling uncomfortable because they don't know, and me not learning anything about the candidate. Another strategy that can be really helpful here is just to pivot to another skill. If we're talking about accessibility and I'm talking to a candidate who's never done it before, we're not going to get very far. So in this case, I might say, hey, let's say that we have to make some design changes, and now we need to go back to talk to the designer or to a project stakeholder and explain why that needs to happen and get them on board with us. How would you do that? What would you think about? And this is great because it gives the candidate, again, an opportunity to show me something, even if it's not the something I was originally going for with the question. And this can also be really useful if you have a candidate who is much more experienced with something than you are, because I've definitely run into the situation where a candidate knows way more than I do about something, to the point where I'm not able to accurately assess them anymore. And this helps us to continue to have a conversation where they can continue to show me new things, because I've already written them down as off the charts on that particular thing. All right, another thing that can be helpful for those more experienced candidates is to make the problem more difficult. So again, we want to stay pretty specific. So in this case, one thing I might do is say, all right, let's add columns that the user can adjust the width of. How do we keep that accessible? And that gives them another challenge to work off of. It gives them, again, a way to demonstrate to me some more deep skills, but we're still on the same page. And we're still having a good conversation about accessibility and how to apply it. All right, and then the other thing that we can run into is a candidate who tells us part of what we were hoping to hear, but doesn't get to everything. And we're kind of left wondering, do they know all of it? Or do they just know that part? Or did they forget the other part because they're nervous? So, for instance, if I'm talking about accessibility and a candidate just mentions ARIA, one of the things I can do is just be really direct in response to that and say, hey, when do we want to use ARIA? And when do we want to use semantic HTML? How do we make that decision? And it's not like by saying that I'm telling them all about semantic HTML or giving them the answer. I'm just helping to guide the conversation so that it can be more productive, and so that at the end, I'm not guessing about how much they know and what they can do. The other thing that can be helpful here is to ask about a candidate's personal experience. Everybody can talk about the projects that we've worked on with more detail than people can talk about some abstract example. And this can also give you really helpful material for the rest of the interview, because you can kind of keep referring back to some of these same experiences. And you're also going to get information about what people have actually done in real life, which is probably a better predictor of their future behavior than what they imagine they might do. So, as you can see, lots of different strategies. These are all appropriate ways to adjust the conversation based on the candidate who's in front of you. So another thing that I want to emphasize here is that using concrete examples is really helpful. Unfortunately, I've had a lot of experiences where I'm talking to the candidate and I ask a question that I think is really clear, and there's some jargon in there that the candidate just isn't familiar with for whatever reason. And often this can happen with people who are really experienced, who just haven't brushed up on exactly which words go with which skills right now. And then we spend a lot of time just trying to get on the same page about what I'm even asking them. And that time isn't useful for them, and it's not useful for me. So concrete examples allow us to sidestep that entirely. And I think they also allow people to show up, again, more in the way that they will normally show up to their jobs, because it's putting them into a more familiar situation. The other thing I should say about this is I did not come up with all of those examples on the previous slides just on the fly. I know some really skilled engineers who can do that, and it's so incredible to watch them interview, but I can't do that. I have to prepare ahead of time, and I have to really think about what the candidate might say, what I might say, and find questions I like and kind of keep coming back to those. And I'm telling you that just so you know, if you are like that too, that is okay. Put in the work, it's worth it. And one thing I want to emphasize here too is that it is okay to do a lot of coaching. I think sometimes we get this feeling like the interview is somehow supposed to be like a quiz and the candidate is getting graded on their answers, but it really is more about how they get there than what the final answer is. And you are there, you're watching the interview, you're having the conversation with them. So you'll know at the end when you're providing your feedback, you'll know how much you helped them, and you'll know what they came up with unprompted, and you'll know what they were like as they were getting there. So just make sure that that's reflected in your feedback and you'll be fine. And that brings us to feedback, which is a really important part of the interview process. In fact, unless you're the hiring manager for the role, the feedback that you give about a technical interview is the main point of doing that interview. So it's worth taking the time to do it right. Couple of things about what's helped me to be good at this. The first is I have to capture feedback when it's really fresh in my head. I, in the past, have had a call with a colleague immediately after we did an interview together, and already our memories from the interview are starting to kind of drift apart, and we have to remind each other exactly what happened. So if I spend too much time thinking about something else, I really can't provide useful feedback. And calendars can be really tough sometimes, so if you have to jump into another meeting right away, just try and take some notes for yourself maybe about anything that really stood out to you or any specific things you want to make sure you mention. And then when you have time, you can come back and reflect on those notes and get back into that headspace. And I do think it's important to make that space to really think about the candidate and think about the interview. And it takes me between 15 and 30 minutes to provide feedback, and our technical interviews are an hour. So I'm telling you that just to say, however long it takes you is how long it takes you. But this is a really important part of the hiring process, and it's worth it to invest the time in it now, because getting it wrong takes a lot more time, whether that means incorrectly rejecting a candidate or recommending a candidate move forward when that turns out to be a waste of their time and the company's time. So the other thing that is really helpful here is we probably want to go beyond just yes or no in our feedback. I try and frame this for the hiring manager as, these are the things that I think will make the candidate successful. And these are the areas where I think they might need a little bit more support or coaching, or maybe just some more time to come up to speed. And those details are really useful to a hiring manager. For instance, if there are multiple strong candidates for a role, that they can only hire one, that helps them compare candidates better. It also helps if there is one candidate and multiple roles that they could hire into. It helps them to decide what's going to be the better fit for this particular person. And that makes everybody happier and makes all of us able to succeed more. So it's worth it. The other thing that, again, I think is really helpful here, just like it is in the interview, is to provide concrete examples and kind of show your work for the person reviewing your feedback. One thing that could happen is I don't have all the context for a person being hired and what role we're hiring them into. So maybe I ask them like a pretty basic CSS question and the candidate says, I'm not really familiar with that. I would have to get back to you. And my first reaction to that as an interviewer is like, oh, great. It's nice that they were honest with me. But if the hiring manager knows something I don't, like let's say the hiring manager knows we're trying to hire that candidate to do all this fit and finish work on our brand new design library, and we really need them to know CSS backwards and forwards, it's important for the hiring manager to know how I came to that decision that the candidate was honest, because that will give them other information about whether or not the role that we're looking at is the right fit. And then the last thing I want to emphasize here is we want to provide feedback on the whole candidate. It can be easy to feel like because this is called a technical interview that we're really only looking at people's mastery of specific skills. But the whole time we're interviewing somebody, we're evaluating their ability to communicate clearly about technical concepts. And there are just a lot of skills that go into being a good engineer, whether that's having a skill for writing clear documentation, or having empathy for your users or your teammates, or having a really good business sense and knowing when to bring other people in and how to make good decisions with the information you have in front of you. These are all really important things. So we should include things that are relevant to all of these skills in our feedback. And that actually brings me to my secret second main point of this talk. I think that technical interviews are really actually behavioral interviews. I think that how we get to the answer is more important than what the answer is. And I think that because in my experience, it's much easier to teach somebody a particular language feature or to coach them out of a particular bad habit than it is to change something that's closer to their personality. So I would rather say to somebody, hey, we found that ternary statements make our code base a little bit better to maintain. So we try and be careful about how we use them. That takes like 3 minutes. It takes way longer to teach somebody how to be empathetic to users. So I had an experience a few years ago at a different company that I'm still mad about, where a candidate was rejected because the file structure that they used in their homework example didn't match the internal preferences that the company had for how files should be set up for a vanilla JavaScript application. It was just such a waste. And I know it was a waste because my team went back to that candidate, we interviewed them, we hired them, and they were incredibly successful and a huge asset to our team. So make sure that we're paying attention to what the candidate will be like to work with and everything that they'll bring, and not getting blindsided by smaller things that it's easier to teach people out of. All right, I want to leave you with a challenge here, which is to think about how power shows up in our interviews. Whether or not we are the final hiring manager, the final decision maker in a role, we still have power to influence someone's future when we're conducting a technical interview. And I think it's important to be mindful about how we use that power. I also think that we get a lot of messages from the culture around us about what interviews are supposed to be like. And I think a lot of those messages tell us that the imbalance of power between the interviewer and the person being interviewed is important, and that it's the job of the person conducting the interview to really lean into that imbalance of power and maybe even abuse it. And that makes the interviews suck. It's not fun to do that to someone. It's not fun when that's being done to you. And beyond that, that also means that the people who are most likely to get hurt are the people who are already starting from a less powerful place. That could be somebody who comes from a background that's less represented in tech. It could be somebody who's new to the industry, or just somebody who really needs a job right now. But regardless of who it is, we have to remember that interviews are gates, and who we let in and who we keep out influence what our industry looks like. And the good side of this is it means that if we can change what interviews are like, if we can change how interviews feel, we can change what our industry looks like, and we can change who's able to succeed in it. So please be kind to people out there. Conducting your interviews in a way that is kinder and more intentional is going to give you better information about your candidates, more candidates to choose from, and maybe even some really great candidates that other companies are passing on. Thank you.
Hey EmberConf, how's it going? My name is Chris, but you might know me better by my online handle, Zerok. And today I'm here to talk about an exciting new feature that is just landing in the add-on ecosystem just now, and that I'm really looking forward to seeing, especially for how it's going to change how we write Ember applications. And that feature is template imports. So today we'll go over what template imports are, if you haven't been following along in all the RFCs. We'll talk about what they look like in general, and we'll talk about how they work today. So let's get started. First off, what are template imports? Well, if you are an Ember developer today, you probably are familiar with how Ember resolves values in a template. It looks up the value based on its type and where it is in the file system. So if you are invoking a component, it'll look it up in the app/components directory. And if you're invoking a helper, it'll look it up in the app/helpers directory, and so on. Well, in the future, this is going to change. Rather than doing it based on directory structure, you're going to import the values explicitly using JavaScript syntax. And this is going to have a number of benefits. For instance, we're going to have better integration with editors and tooling overall. And we're going to have the ability to have a more flexible file layout. We'll still have strong conventions around our file layout, but you'll be able to have, for instance, components in the same directory as your routes. So if you have a component that's only used in your routes, that'll actually be able to be there with your route definitions, which will be really nice. It'll also work better with bundling and build tools, in particular Embroider, which is really going to be crucial for the future of bundling within Ember. And it also helps to simplify the internals and have better performance overall. So yeah, that's basically what template imports are. So next up, what do they look like? Well, you can imagine as soon as we started talking about this, there were a lot of different ideas about what it should look like in practice. Some folks thought that it could basically be the same as HBS files today, but just with the imports added to the top of them. Another idea was that we could do something like Vue or Svelte, where we have a script portion for our JavaScript and a template portion for our templates. And then another idea was to use the existing HBS helper that you use to define templates in tests and just allow it to also refer to in-scope values. Rather than committing to a high-level API right off the bat, we decided instead to ship a low-level API first. And that's where we're at today. Available in Ember 3.25 and up, you can use precompiled template to define a template that can then be associated with a component. And that can be provided a scope, it can be provided imported values, and so on. This obviously isn't what we want people to be writing in their Ember applications. It's very verbose and requires a lot of understanding of low-level APIs. But it allows us to experiment and move forward as a community together, which is really what the goal was. We also created the Ember Template Imports add-on. And the idea there is that rather than having a competition where it's all based on name recognition and so on, we would have a single place where we can share all of the different implementations of template imports, and we can work together and share common infrastructure. So if you have an idea for template import syntaxes, please, PRs are welcome, open up an issue. We're happy to add more and happy for the help. Now finally, let's talk about how template imports work in practice today using the Ember Template Imports add-on. So far, we only have two different formats supported, and they're kind of similar to each other. The first one is to use the HBS helper like you would in Ember tests today. And the second one is a new file format called GJS. In the first format, in JavaScript files, we can see using the HBS helper, we can just define a template-only component like so. Export default HBS, hello world, and there's your template-only component. In the GJS file, we use this syntax, this special syntax of defining a template using angle bracket template. And we put our template inside of that, and it automatically becomes the default export of that file because it's a top-level template. We can also see how we would use imported values within these templates. We can just import them and then reference them directly from the template itself. We don't have to do anything else beyond that. Another really cool feature about these formats is that it also allows us to actually define those values that we reference in the same file. And this is one of the most exciting things about template imports to me. This means you can define a helper in the same file, or a modifier or another component in the same file as your template-only component. And that makes it much more flexible overall. It means that your template-only component can now have derived state. You can have private modifiers. You don't need to create a class in basically any case, unless you possibly want to add some state. So let's see what that looks like. Here we add a track property to a component class, and we define the template for that component class. In both cases, the template is defined within the class body. In the HBS backtick case, it is assigned to the static template property because it has to be valid JavaScript. And in the GJS case, we just define it in the body using our special syntax, and it associates it based on it being inside the class body. So yeah, that's what these formats look like overall. And like I said before, we are definitely really excited about this and also open to new ideas, new PRs in general. The whole point of this period is to figure out what the details are, to figure out what the tooling looks like, what the build support looks like, what the ecosystem support looks like. And let's climb the mountain together. All right. Thank you.
Hi guys, welcome to EmberConf 2021. My name is Amin Mahmood and I am from Pakistan. I am running a small IT service provider company named Ala Solutions, and we use Ember on daily basis to serve the needs of our clients. We used Ember for desktop applications, mobile applications, and as you know, the web applications. So let's begin the journey. I would like to say big thanks to my cat because she really helped me during the preparation of this presentation, and as you can see that she's really helpful. Okay, so as in every application, there is a beginning. To start a new application, we have this command ember new, and next the project name. For the sake of this presentation, we are going to use a simple listing of jobs, and I have created a mock server with some jobs on there, and to deal with that we are going to use a job model, and here is the model. And after creating the model, we would be using an adapter because an adapter is needed to communicate with the server. Here you can see that I'm using a REST adapter and my mock server is on this URL. So Ember should know that where the data is coming from. After that, definitely some UI is very important because that's what the user will be seeing. For this example, I have used Semantic UI and they have Ember component as well. You can use that, but I just used their CSS from the CDN. So this is the current output so far. Let me show you some code. Okay, this is the model and this is the router. You can see that in the router I have two paths. One is home and this is pointed to the root of the application, and the other one is the details. So when user will click on a job, it will open a details page, and that detail page will show all the other information to the user which might help him score a job. Okay, and on the home I'm just fetching the job from the store. This is a very standard Ember data model. This is how I'm presenting the jobs. These classes are from the Semantic UI, and when jobs are fetched, used each helper to loop over all the jobs and created a link to the details route using the model ID, and then presented some of the details. And if I show you the example, this is the output on the Safari. Now when user would click on any of the job, it will open the details, and for the details I'm just passing a single record job ID which is coming from model from the link and passing that here, and in the details HPS file, template file, I'm just presenting the contents. So that's pretty straightforward. Now let's move to the next step. Now let's create a progressive web app. To create a progressive web app, we need a couple of the add-ons to be installed. Number one is to make web app, we need Ember web app component. Oh, sorry, pardon me. Ember web app add-on, because every progressive web app requires a manifest file which tells the browser how to deal with that. After that, we are going to install Ember Service Worker, which will take your application offline, and there are a bunch of add-ons for that. Ember Service Worker is the basic one. To make offline, you need to install these one. The index one just caches the index file and JS file. Asset cache will cache the images folder, the assets folder in the public path, and the cache fallback would cache your external URLs. I'll show you how. So in Ember CLI build, we are going to add some configuration. Number one is the version strategy for the progressive web app. We need that version to be updated every build. And for the cache part, I'm going to cache all the requests made to the mock server, which I have mentioned here, that application doctor. And I'm also going to cache this semantic CSS from the CDN. After that, in the manifest file, that can be found in the config folder. Okay. So here I would like my application to be full screen. This is the name, these are the colors and the icon, and that's it. So let me show you a progressive web app. Just go to pwa.alasolutions.com, and here app is running. Click share icon, add to home page, and it is added. Okay, now if you open that, you will see that it is showing all the contents. And if I turn off my internet, then if I run this application again, okay, you would see that, yep, see, content is loaded without the internet. Okay, so this is the progressive web app. Now coming to the next step for the mobile development. For that, I have just created a separate branch to just save the time. I have already installed different packages which were needed. So the Corber.io is a Cordova wrapper for single page applications. To install Corber, we just need to install the global package first. You can use Yarn or Node npm package manager, and then in your project just type Corber in it and Corber start, and it would definitely start the project. So let me show you how this is going to work. Go start. Okay, so I need to reinstall the packages. Because I switch the branches, and sometimes this happens that the yarn log file is different for each one, and we need to update. Okay. and you can see that it is working. Okay, let's run that in a simulator. Okay, let me open this project in Xcode. Yeah, okay. So we are going to install this as a mobile application, and if you already have worked with Cordova, you know how the process of that. You can change the different settings like icon and the permissions and push notifications, everything for that. All the Cordova add-ons like notifications, camera access, etc. would definitely work with Cobra as well. And okay, so you can see that this is running as an application. And when you hit publish from the Xcode, you are going to definitely, you need to provide the details, and you would be able to publish this application on the App Store and Play Store. Now let's move to the other point. There are some settings which you can check on the Core.io. Last part of my presentation is Electron. To use Electron, we need to install another add-on, and then we can simply run. Okay. To install Electron, I'm going to use the beta version because they are using the latest Electron version, which really supported us with the latest features, like we need to install thermal printer for a POS module, POS application, which we developed in Ember, and in the older versions that thermal printer was not accessible or giving us some trouble. And that's why I would also recommend to you guys to use the beta version. And after that, just run Ember Electron. And usually jar again, I need to run the package again. And here, your desktop application is ready, which is working. Now let me make a package for that. This will create the package, compile package for you guys, which you can just send to your customers, put online for downloading. And there are other lots of settings like changing the icon, adding custom menu items in the Electron application. For that, you should go to the Electron website, and read their documentation. I guess my package is ready. Here you would see that out folder, and okay, so here my Ember application is now ready to be used as an desktop application. So that's it. I would say big thanks to Ember team. I really enjoyed working with Ember, and I'm working with Ember for a long time. I would like to thank all of the services like Ember Service Worker, the Ember Web App, Corber.io, Electron.js, and most definitely Ember Observer, because if I need to find any add-on for Ember, I would definitely search over here, because this is the only best place to find Ember add-ons. Okay guys, thank you, and please enjoy the rest of the conference. Take care, bye bye.
Hi, my name is Gonzalo, and welcome to my talk, Bird's Eye View of Ember. A bit about me before we start. I'm a computer engineer in London. I'm one of the organizers of Code Bar London, where we run free programming workshops for minority groups in tech. I work at CrowdStrike, and while I've been working with Ember.js for the past half year, before I spent 5 years working with Vue.js. This talk is about these 6 months that I've been trying to map my Vue knowledge into Ember. First things first, what is this talk about? Basically, I want you to know that if you already know Vue, you basically already know Ember as well. I want this talk to be a brief but useful reference for Vue developers new to Ember. I'll be focusing on Ember, Octane, and Vue 3, since they are the most recent embodiments of each framework. What is this talk not about that's equally important? This is not about setting frameworks against each other. It's not about the technical details underlying the differences. It's not about favorites. And it's also not going to be an extensive presentation. I'm going to focus on useful and popular Vue features. I want to start with these two diagrams. The first one comes from a presentation from Evan Yu, Vue's creator, and the second one comes from Ember documentation. I find them useful to describe the ethos of each framework. Vue is designed to be incrementally adoptable, where the code is focused on the Vue layer only, and then you pick your functionalities along the way if you need them. Ember, on the other hand, labels itself as a battle-tested JavaScript framework for building modern web applications. Most of the features you would need to build rich single-page applications are already built into the framework. This difference in philosophy will run deep through the mappings that I'll be doing throughout this presentation. Let's start with our command line interfaces, or CLIs. These are tools you run in a terminal and allow you to create projects, add extensions, run tasks, etc. Vue CLI is official but entirely optional, in line with its philosophy. You adopt it if it adds something to your use case. Ember CLI is a bit more ubiquitous, used by pretty much the whole community. You create your project with it, you can scaffold every piece of your application with it, and you also use it to install add-ons, run tests, and serve your application. Next up, we have components, your building blocks in both frameworks. On the Vue side, the component itself is highlighted in bold. We're registering it on our app with a name, an internal state with a data function, and a template defined as a string. The rest of the lines are basically a Vue application that we are creating and setting an instance of this button as our template. On the Ember side, we have the same component split between files 1 and 2. 1 is the template in a handlebars file, and 2 is the JavaScript counterpart of it. File 3 is how we would use that component on a page template, for example. Note that if you don't need JavaScript for a particular component, like functional components in Vue, you don't need to create the JS file. On the previous slide, I talked about Ember's CLI generator. The Ember generate command that you see allows you to create new components with the corresponding handlebars and JavaScript file and its component test even. If you're coming from a Vue background, you're probably a big fan of single file components, where you define the template, behavior, and styling of your components in a single file. Unfortunately, there's no such thing in Ember, at least for now. However, there are some initiatives and projects exploring similar concepts. This one over here is just one example provided through a package called Ember Template Import. Now that we have components, how do we pass data into them? In Vue, they are called props, and you have to explicitly declare them on a component, like setting an API, as you can see on file 1. On file 2, you see how to use them. Notice the script tag where you have to explicitly import and declare your component. Component imports are explicit in Vue. On the Ember side, props are called arguments and are passed with the @ symbol. You don't explicitly declare them, so coming from Vue, this was something that I had to get used to. However, with the advent of TypeScript, you can define your arguments as its own type or interface, and the language will do the checking for you, for example. Now that we have components and we're passing data into them, how about tracking state and reacting to changes? Here we have a single file component in Vue with a starting state called defined by data, a computed property that reacts to any of their dis properties change, and a watch that looks into a reactive property and gets triggered whenever its value changes. This is where I struggled the most coming into Ember, kind of moving from an explicit declaration of what I want to a more vanilla JavaScript-looking way of writing things. I do believe that this is simpler than Vue, now that I was able to follow a more Ember-like approach. The way I see it is, you set your reactive data with tracked. Your computed from Vue becomes regular JavaScript getters that automatically react to changes, and you try to stay away from observer as much as possible. One of the guidelines in Ember is data down, actions up, where you pass arguments to communicate down the tree, and you trigger actions upwards. However, when you use observers, you are breaking this paradigm, using data to trigger changes instead of actions, which usually leads to issues. Let's briefly look at native events like click or focus. In Vue, you set them as v-on event name or at event name, and you can inline an action or call a method from your component. In Ember, this is pretty similar. You rely on the on modifier. However, you can't inline JavaScript as your action. You need to stick to handlebar helpers or actions from your components, which are JavaScript functions, as you can see from that handle click. Custom events deserve a mention as well, since this is how Vue components usually communicate with their parents. On file 1, you can see a custom button where, when it is clicked, an event of our own choosing, called custom click, is being emitted. You can see on file 2 how to intercept it to trigger an event, to trigger a method on the component listening to this custom event. In Ember, going back to data down actions up paradigm, you can see on files 1 and 2 our own custom button reacting to a click, but instead of sending a message upwards, it's calling instead a function it receives as an argument. This is how you leverage parent-child communication in Ember. A quick stop on Vue's custom directives, which are a neat way to encapsulate DOM low-level access into reusable helpers that enhance developer experience. You can do a similar thing in Ember with certain helpers like did insert, for example, but you can get a perfect match with Vue by installing Ember modifier, as you can see from the code. You can almost match Vue's code line by line and add it to any element you want pretty much the same way. Besides passing data to feed components, we might actually have components that just wrap around other large components or complex information. For these cases, Vue has slots. File 1 is our component, defining a slot area where content will be injected. File 2 shows us how to use that component. Notice how it wraps around the string add to do. In Ember, these are called blocks. And with a similar fashion, although notice again how we had to explicitly import and declare our component in Vue, but that happens automatically in Ember. File 1 is our component, and File 2 shows us how to use it. In both cases, the resulting HTML will be the same, as you can see on that red box. When you want something more complicated than a button, like a modal, a component that would need different areas of content, like a header, a content, and a footer, you can use named slots or named blocks. This is how Vue makes it happen. You still use the slot keyword, but you name them so they all end up in the right place. In Ember, I believe starting from version 3.25 upwards, this is available as well. The syntax is a bit more compact, but it's similar to Vue. You use yields instead of slots, you name them accordingly to the block, and voila. As your application gets bigger and more complex, you need to start sharing state between several places of your app. In Vue, it's very common to bring in Vuex. You define a store or multiple stores. You define their starting date. You define getters and setters, or mutations, and you inject that store into your application for your components to use. Besides this, Vue 3 brings a new dependency injection mechanism, where you provide the data you want from the top of your hierarchy, and then you inject it explicitly on each component that needs it. In Ember, I would say there are two main ways of sharing state across your application. First off, services are an important tool that you have at your disposal in Ember. They are singletons, which mean they live throughout the lifespan of your session, allowing them to keep state if you want, and you can inject them into any component by their name. Secondly, Ember data, for example, provides you with a very popular object relational mapping, or ORM, where you can keep your state in models you might want to persist in a database, like a shopping cart, for example. If you're building a single page application with different pages, having some kind of routing is pivotal. Vue Router is the official package for Vue, and you can see on the left a full Vue application with a functioning router. Everything is based on components. So you declare your top level components. In this case, basic template is enough. You map each top level component to a root. You create a router with the roots you created, and you create a Vue application that will use that router. Notice that the app's template and the router link, that's where the page component will be inserted. Ember follows a similar pattern, but splits it differently. You define your roots in the app router. You use the link to element to navigate them, and your actually pages will be usually folders under the app folder that correspond to the roots you defined previously, and that will contain a template handlebars file. If you remember this diagram I showed at the beginning, this is one of the main design principles in Ember that I had to get used to. Everything stems from the root. It is responsible for initiating the full loading of a model, page template, and corresponding components. Going back to global state, now that we've introduced roots, we can talk about where to get your data from and where to keep it. Vue provides no official guideline on this, encouraging you to use whatever you want. If you need something like weight, you're probably just using Vuex stores and some plain old JavaScript objects, POJOs. If you need more than that, you might be using some GraphQL client or some other ORM package. In Ember, Ember data is the default approach for the community. You can use it as a front layer for several different data layers like Firebase, Orbit, and it's a feature-rich ORM. Ember Apollo is another alternative for GraphQL if that's your case. If you only need to use a few POJOs though, remember that services are singletons and they can keep that data for you. About testing, Vue again provides loose official guidance. There's a few official packages like Vue Test Utils and Vue Testing Library, but they only provide you unit tests and component tests. More than that, there are other services and packages that you can bring in. Ember, on the other hand, it ships with generators that create tests for you, and you can create tests for models, components, controllers, whatever, pretty much every piece that you put into an Ember application. Finally, I want to leave you with one of my favorite features from Vue, transitions. The cool thing about it is this transition tag that you can use to wrap elements that will come in or out of the DOM. You can give it the name of a transition, and whenever the wrapping element shows up or disappears, Vue will automatically apply certain CSS classes based on that transition name. In simple terms, you define your transitions in plain CSS, you set them with the correct selectors, and Vue does the heavy lifting for you. When you want to use that in several elements, you use transition group instead. This is one of the few things that Ember doesn't have built in here, but there are powerful add-ons that you can bring the same functionality. I'm just going to highlight two here. Ember CSS transitions allow you to port your exact transitions, your exact Vue transitions as they are, keeping the exact same CSS and replacing the transition tag with the CSS transition helper. Second, you have Ember Animated, which provides you with a rich set of helpers and imports to articulate powerful animations, even between different pages. This GIF, for example, is from Edwards Faulkner's talk of 2018. Finally, I want to provide you with a few links where you can read more about this. Ember Atlas is a great resource. They even have a specific page for Vue developers. Ember Observers to track add-ons and popular packages for Ember. And then you can reach out to the community on Twitter and especially Discord. Thank you so much for this talk. I hope you had a good time.
Hello EmberConf, I'm James Steinbach, and today we're going to be talking about building forms that your mobile users will love. It's easy and unfortunately common to build forms that they won't. Areas where they need to, input where they need to add their email address, but it's getting capitalized. Put in a username, but it's getting autocorrected or spell checked. Type in a number, like a one-time authentication code, and they've got an alpha keyboard. These are all correctable problems. But the point I want to make to start out with is, when we put these hurdles or these pieces of friction through accident or just, being too clever for our own good, sometimes we're guilty of that, I empathize. When we put this friction in a user's path, it seems like a user experience issue, but for many people it is an accessibility issue. And this is the part where Scooby-Doo's gang pulls the white ghost mask off and we find out that underneath it has been accessibility the whole time. Only it's a good guy, not the bad guy here. This is an accessibility talk pretending to be a UX talk in its title and description. But as we talk about accessibility, I want to remove the idea that some people are abled and some people are disabled and the world can be kind of divided up in a binary like that. There's a wide spectrum on all sorts of different axes of various kinds of ability. Right now, my ability level is different from what it was 3 months ago. You can see on screen I'm wearing a neck brace, vertebrae broken in a car accident, as well as broken arm. Right now, I'm interacting with the world and devices in a different way than I did before. I go to my phone as my primary device right now because I can hold it in one hand and type everything I need to on it. I don't like my laptop because typing with one hand is cumbersome and I got to go back and forth and it's tiring on my arm. I don't like my tablet because it's heavy. My phone is the easiest thing, but if the mobile experience for me is bad, say on a banking or insurance or hospital website, man, that is frustrating and hard for me to use. And I don't have the privilege I used to have of just saying, oh, I'll bookmark that and grab my laptop next time I'm downstairs. No, when there's friction in the way of a person whose primary and sometimes only device is a mobile device, that's an accessibility issue. We are all at best just temporarily abled. And there are many different issues that affect what we consider our ability levels. It could be the tablet or the device shape or size or portability we're carrying. It could be a condition in us, low vision, relies on screen reader. It could be a physical illness, something like Parkinson's that causes tremors and inaccurate swipe and tap gestures. It could be a perfectly healthy person riding a bus on a bumpy part of town, and that gives them the same result as tremors. It could be an injury, maybe something as simple as your kid is interrupting you for the third time today asking for help getting Zoom back on for school, but now you've been distracted and your ability has been constrained by something as simple as an interruption. And if you all added your use cases that you've solved for in your careers, we could make the slide 3-4 times longer easily. And sometimes we worry that when we have a bunch of complex use cases, we need to come up with a bunch of complex solutions. And this one needs a media query, and this one needs a different media query, and this one needs some JavaScript, and this one needs a polyfill library loaded, and this one needs a bunch of ARIA attributes, and this one needs... And we get exhausted, we get overwhelmed, and the cognitive load is so heavy, and I empathize. And that's why today, I want to suggest a simpler, more unified approach for solving lots of varied situations without writing lots and lots of varied workarounds. In fact, as few workarounds as possible. And here's a big takeaway. Use semantic markup. And I know that sounds like, duh, James, what else am I going to do? But here we are. It's 2021, and we still have people attaching click events and roll button to a div. That should not be happening. Please don't do that. There is a button element that does that for you, okay? Use semantic markup, not just tags, but we're going to learn today 3 attributes in HTML. They're not part of the ARIA spec. They're just normal HTML attributes, and they have semantic, some of them have semantic payoff in terms of how browsers, assistive tech, and anything else implement our interfaces. 3 awesome benefits here. First, worry less about ARIA. That's right, I said worry less about it. Studies have shown that the more websites use ARIA attributes, the more they miss and overuse them. Unfortunately, the same sites that are really high in ARIA attribute, bolt everything on, are high in accessibility errors. Here's a rule of thumb. A vague UI is better than an incorrect UI. When in doubt, don't just copy paste, don't just cargo call a bunch of Stack Overflow in. Make sure that the ARIA attributes you're using come from a reputable expert and they really do solve the problem you need to work on. We're only going to look at one ARIA attribute today, in fact, and we're only going to look at it briefly in passing before we get into the heart of the talk. Second benefit is writing less JavaScript. Wait a second, it's a JavaScript framework conference. Why should we write less? Because the less you write, the less you have to test and the easier your workload is. Also, the less you write, the less you send to your users, the less they download, the more power efficient everybody's devices are, and the faster your site is for everyone. That's a fantastic benefit. Everyone wins there. And then third, future-proof your apps. We're going to look at the way HTML attributes are mapped to accessibility API data points and see how much we get for free today. Future interfaces and devices and software that haven't even been invented yet are going to follow those same standards if they're compliant devices and software. And so we are going to be future-proofing our apps by doing by doing semantics correctly as a baseline. So here's a foundation for how to make an input that will be rendered and handled correctly on any device. You need a label attached to every input. The code golf winner here, the fewest keystrokes is wrap your label around the label text and around the input element. This is great. Assistive Tech knows how to announce that correctly to screen readers as associated boom. They're linked. And if you are a desktop user or something like that, a user with sighted ability, and you tap or click on the label, you'll automatically be focused on the input. Super handy. You didn't have to write a click event for that, developers. The browser did it for free. Sometimes we want to style our label and our input as siblings, and in that case, we separate them like this. We give the input an ID, we give the label a for attribute that matches that ID, and now they're linked in the exact same way, all the same behaviors in accessibility, assistive tech, and in browsers. You might not like repeating all the ID stuff. That feels really kind of, boring. So you could write a reusable component that has label and input as a pair, and you might be tempted to have to pass the ID in as a prop, but you don't need to. There's an RFC here linked for an Ember helper called unique ID, and every time you instantiate that, you get a unique ID. Let the computer write all those IDs and fors for you. You don't have to worry about human error, accidentally duplicating an ID. That's invalid HTML. You don't have to worry about making choices and thinking about boring, repetitive, okay, I guess I need an ID here. Just let the computer make those boring choices for you. Super awesome. Last scenario, a little bit of a bonus. Sometimes you need a paragraph of text to describe your input, but it's not the label. It's maybe a hint you need ahead of time, or perhaps an error message that comes back after a validation event. In that case, give that paragraph an ID, and only ARIA attribute I'm telling you today. Put the paragraph's ID into ARIA described by on the input. This is one of the unfortunate areas where HTML doesn't have a way to semantically link that input with a separate paragraph, but the ARIA spec provides this ARIA described by attribute that does do that for screen readers. So with that out of the way, let's jump into 3 HTML attributes. They're plain old boring attributes. They're not part of the ARIA spec. They don't feel really complicated or hyphenated. And the first one's going to be really familiar to you. In fact, I would be willing to wager that probably high 90s% of y'all watching have used this attribute. Type has values like email, password, or radio, checkbox. This semantically identifies the type of value or content the input can hold or accept. And that's semantic information because it is passed along to the accessibility API mapping for various models of assistive tech, and it can suggest more specific labels or other data to screen readers or any other application or device. Here's a screen cap from the AAM specification site. This is the HTML version of the AAM spec. And if we use input type password, we get a whole bunch of things passed right along to 4 different assistive tech accessibility APIs in various ways. All this information is used by their accessibility models to make it easier for their users to fill out the site. And it's all for free just by using the right type attribute. You shouldn't try to implement passwords as something other than a password. We try to make them text, but that's a different talk entirely, the whole show password button. Autocomplete is another really useful attribute we're going to practice today. This tells browsers or plugins or software or anything what user data to offer as an autocomplete option. Even better than making it really easy for users to type their answers to our form fields, let them get away without typing at all. Let them just tap once on an autocomplete option. This also is mapped to a supports autocompletion state in a couple different accessibility API models here. Third and final attribute we're going to focus on today is called input mode, and it suggests the right on-screen keyboard for a device to show to users. This does not have any AAM mappings, so I don't have a screenshot of another one of these tables for you, which means it's just presentational. It's not part of accessibility. Let's practice using these attributes in our last few minutes together now, shall we? Couple notes before we get into these. I've got Android in the middle and iOS on the end. I've got code blocks that only show you the input. I did not include the label, but you still need labels, okay? What I said earlier about labels still applies. I just shortened my code blocks for these slides. Here, a user needs to add their username. Maybe they're creating it, maybe they're signing back in. There's not a type value that's semantically appropriate for usernames. We just go ahead and use text, which is the default. But we do add autocomplete username, and that tells password managers with browser plugins or OS integration, as well as the mobile operating system, which might see the user's contact card having a handle saved for the particular domain. Autocomplete options are provided. You might notice here that our keyboard is lowercase. That's not normal. Normally iOS and Android have uppercase keyboards by default. We turned off auto capitalize, auto correct, and spell check with the 3 bonus attributes here. I'm not going to show you those again. Those are just here if you need them on the slide deck and want to refer back to them. But if we look at the email option here, the next thing you might want a user to submit, you can see we're still on a lowercase keyboard. We've also got the @ symbol available right away with no modifier keys. But the browsers and mobile operating systems have disabled spell check, spell check, auto capitalize, and auto correct simply by fact of this being a type email. All that UI accessibility stuff came for free with us simply using the correct attribute, type email. And then that gets us this on-screen keyboard, and then autocomplete email gets us the autocomplete options you see above the iOS keyboard. My Android experience is just an emulator here, unfortunately, and I couldn't set up a contact card. But I did confirm with other Android users that yes, indeed, autocomplete is a super helpful feature on Android versions as well. Telephone number looks basically the same. Not going to spend a ton of time here, but you get the telephone keyboard and autocomplete options by using type tel for the keyboard and autocomplete tel for autocomplete. Addresses are common. Type text is all we need there. There's not a semantic value related to physical location. There are autocomplete options that help us here. Street address is the first one. City, state, zip code, country are other valid values for autocomplete. And the awesome payoff here is if you mark those inputs all up correctly together, one tap fills in 5 or 6 inputs. Very handy. Numbers are tricky. There's type number, and on a desktop computer, this has little up and down arrows at the end of the input itself. It also responds to key presses for the up and down arrows for incrementing or decrementing the number. And on some browsers, you can even scroll over an input type number, and that will increment or decrement. That's not what we want most of the time. It is what we want if, say, we're doing like a font size chooser or a scale UI in something like a Canva no-code design tool on the web. Input type number might be really useful there. But most of the time, the forms we build want users to type in numbers that don't have increment or decrement baked in. Nobody wants to increment their credit card number or their one-time authentication code or their zip code. In that case, we've really actually got an input that's typed text that just coincidentally happens to only need digits in the text field. And for that, here's what we don't do. We do not do an unfortunately too common Stack Overflow option, which says, oh, just use type tel and get the telephone keyboard. No. Credit card numbers and zip codes and authentication codes are not telephone numbers. So we never send false information through our HTML to any kind of accessibility software or devices. Instead, we use type text. Being a little more vague is better than being wrong. And we use input mode equals decimal to get the on-screen keyboard that mobile users are going to want to see. Super handy. Verification codes like a 2-factor auth Follows the same pattern. Autocomplete is one-time code, is our extra addition to this slide. Dates can be handled as a type date. It's got some UI issues, though, that are a concern. If you're on iOS or certain versions of touchscreen Windows devices with older Edge, you get like 3 spinning wheels, and those are really challenging to spin if you have anything preventing you from being really precise with swiping and tap gestures. It can be really hard to line those up. Android uses a rectangle that kind of covers most of the browser window, and it provides calendar-shaped grids of numbers, and you kind of have to tap your way through them to get to different months and years, etc. Those tap targets on Android are really, really tiny and also hard to use for people with imprecise tap ability, as well as the fact that if the date you need to get to is more than a few months ago, it's going to take a long time to tap your way through to where you're going. Imagine trying to find your college graduation date from 8 or 12 years ago and having to go month by month to that. It's hard. You really just want to type at that point. And you can do that. We can write an input that's actually 3 inputs. I like to call this a compound input. And each one of these follows our text decimal pattern. We've got length helpers for our native HTML5 validation in browsers that support it. And to wrap this all up really semantically, a bigger code block, each of those inputs needs its own label. And then we wrap the whole compound input set in a field set, and we give it a legend, which acts as a meta label for all 3 of the sub inputs, if you want to call them that. And this is, for many users, a much quicker way to type and tab their way through the inputs. We're providing a description of what content as well as what format right there in our label. So very semantic and user friendly. And there's more. You've got input mode and type for URLs. There's autocomplete values for anything related to a credit card as well as a birth date. Tons of cool stuff. CSS tip. Sometimes iOS zooms in and out of form fields. What gives? Why is it doing that? It does that if the form field, input, text area, or select is less than 16 pixels calculated font size. Whether it's ems or rems or percents, however you wrote the number, if it comes out to less than 16, you'll get a zoom behavior. For a long time, people tried to turn that off with a meta tag. User scale is 0, and that's horrible. That disables pinch to zoom entirely, which is an accessibility anti-pattern. Very bad. Instead, we should make sure that all of our inputs, text areas, and selects have a font size of at least 16 pixels. Again, define them in ems or rems or calc with VW and pixels or whatever, as long as it calculates down to 16 pixels or higher. Also, save your users some cognitive load. A single column layout is much simpler to go down than having to zag back and forth through horizontal scanning as well. So, wrapping it all up, we said this talk is really about solving accessibility issues, making sure more and more users can access what's behind a form on our apps and sites. By solving these accessibility issues at the semantic level, we improved our UIs right now for existing technology, and we've future-proofed those interfaces as well for years and devices and users to come. Here's some awesome resources, way more information than I could even fit in this talk. You'll see more examples there. And thanks so much for being a great audience. I would love to continue the conversation if you have follow-up questions. I'm in the Discord now. I'm also JD Steinbach on Twitter, GitHub, and at my blog. Please feel free to contact me, and have a great rest of your EmberConf. Take care.
Hello everyone, I'm super excited to be here at EmberConf this year. I've attended this conference multiple times, but this is my first time being on this side of the microphone, and I'm excited to share some of my knowledge with the community that has taught me so much over the years. First, a little about myself. My name is Joshua Lawrence, and I've spent the last 6 years at LinkedIn as a member of our Developer Experience team, building internal tools to help our engineers work more efficiently. For most of that time, I had been leading a team that owns a tool called CRT, or the Centralized Release Tool, which is an Ember-based web app that our engineers use to track builds and release code at LinkedIn. When I started building CRT over 5 years ago, we were on Ember 1.13. This app has been through just about every change and new feature the Ember core has been through. Engines, check. Pods, check. Native classes, check. And the list goes on. This app has seen it all and continued to steadily grow in size and complexity. After being around this long, I thought we could handle anything. That is, until recently when we attempted to upgrade to Octane and realized one technical decision we had made years ago may have cost us big. I know a lot of you out there have been working with Ember for some time now and also have long-lived apps. But even if you just finished running Ember new for the first time, one thing we all have in common is we're always peering into our crystal balls trying to best predict what the future holds for our apps, for Ember, for the JavaScript ecosystem, and the web as a whole. But the truth is nobody knows where we're heading with certainty, and the decisions we make that work well today may not work so well in the future. This talk is about how to get back on track when we find ourselves coded into a corner due to unforeseeable changes in an ever-changing ecosystem. In the case of my team, the seed of our discontent was sowed years ago from an unlikely source, when we decided we wanted argument type checking for our components. We were frustrated by our inability to tell which properties were arguments and what types the arguments were. Take this example. Someone on your team tells you, oh, there's a component for that already called Ember Mascot. Go use that. So off you go to look at how it's being used in your app. So here's our Ember Mascot component, and let's see. Okay, the name argument is probably a string, and the likes argument is, I don't know what. It could be a number, but perhaps it's a Boolean. It could also be an array, I suppose. And I wonder if there are any more arguments that it accepts. I guess we'll have to look at the template file. Okay, so here's the name arg we saw before, but what is like count? It uses this instead of an at. But that could just mean that it's still an argument, just with a default value. I wonder if it's a number or a string, or a Boolean maybe? And likes is an array, we can see here, but an array of what? Is it an object, a Boolean? I guess we'll look at the mascot like component. And down the rabbit hole we go. The first solution we implemented was to explicitly define every argument in the component class and add typed information using JS-doc. And that gave us a good starting point. But over time we found that these comments would become outdated and inaccurate, which was even worse than having nothing at all. So we found a way to enforce types via an add-on called Ember Prop Types. Now this worked for us for a time, but we weren't entirely happy for various reasons, and eventually settled on a library called Ember Decorators/argument, which I'll refer to simply as argument decorators. As you can see, with argument decorators implemented, all arguments are clearly defined in the component's JS file and identified with the argument decorator. We also now have easy-to-find type information that is enforced during development. We were convinced this was the most complete solution for argument type checking, and we happily implemented it in every component in our app. And all was well until Ember 3.13. Long story short, the argument decorators library was not compatible with changes made in Ember 3.13 related to Glimmer component support. Even worse, there seemed to be no plans to fix the issue with the library, and that being the case, we couldn't update our app past Ember 3.12. Our ability to upgrade Ember had been jeopardized by our adoption of a pattern in library, which we implemented in the name of craftsmanship and reliability. We couldn't believe that such a well-intentioned and seemingly benign decision made years ago had morphed over time to get us completely stuck. But like I said, nobody can see the future, right? So what should we do? Remove all the decorators and give up years of meticulous type definitions just so we can upgrade? Should we get everyone on the team to brute force update a huge amount of components back to the previous approach? Can we do some crazy regex, find and replace? Or what if we stay on Ember 3.12 forever? We decided to seek the wisdom of some Ember masters and set up a meeting with none other than Robert Jackson and Chris Garrett of Ember fame. In the meeting, Chris introduced us to a new library called Ember Argument Types, which would solve our problem if we could migrate to it. The only problem was that the migration would require moving all of our type definitions from our component class to the template. So why the template, you ask? Well, Octane introduced the concept of template-only components, which don't need to be backed by a class. So the question for argument type checkers like us becomes, so where do we type check the arguments? Chris explained that Ember Argument Types provides a way to type check component arguments in the template via helpers, and is thus the most future-proof solution available. By this time, we had over 400 components using argument decorators, and the thought of moving them to the template was daunting to say the least. Robert Jackson suggested we use code mods to do the migration, and that's where the real story begins. Now, before we dive into the world of writing code mods, it is worth noting that if your app needs to migrate to newer patterns related to changes in Ember itself, there are likely already code mods to handle your case in the Ember Code Mods repo. Since our patterns were based on a third-party add-on, we didn't have that luxury. The good news was that when we implemented argument decorators, we treated its usage as if it were an extension of the Ember core and were consistent throughout our app. This consistency throughout our codebase made code mods a much more viable and useful tool. So pro tip, you can learn a lot by watching how the Ember core deals with migrating code through an ever-changing ecosystem, and apply similar principles to how you manage migrations with your app code. Now back to the story. At this time, I knew fairly little about code mods other than they were magic. They were written by some wizards who lived on GitHub, and the ones I had used were written to support migrating Ember core features, not patterns implemented by third-party libraries. So the idea of writing one was not something I had seriously considered. I did at least have a basic understanding of what code mods were, scripts that refactor your code. I also knew that JS CodeShift was the library of choice for performing code mods. Let's take a quick look at it now. When you get started with JS CodeShift, which I hope you do after watching this presentation, the first thing you need to be aware of is the docs are lacking. Which is to say, there aren't really docs outside of the source, so be thankful GitHub has go-to-definition support. There's a great opportunity here for anyone who enjoys writing documentation to help out a broad community of front-end developers get started with JS CodeShift by contributing guides back to the project. Now regardless, you'll want to at least look at the repo's README to get your bearings, and for us Ember fans, you'll also want to, if you'll find it useful, to browse through some of the Ember Code Mods repos. There are also many blog posts on JS CodeShift, most of which give basic tutorials for how to get started. Now before you start opening a bunch of tabs to dig into all this, let me give you a high-level overview of how JS CodeShift works. The basic idea is pretty straightforward. You start with a source code file as an input to a JS CodeShift transform, which is really just a node script. The transform then uses a parser to convert the code into an abstract syntax tree, or AST, that allows us to select individual pieces of code and perform some sort of mutation on it. Finally, we convert the updated AST back into source code and save it to the input file. Now, a note on ASTs. If when you hear this term you immediately think of JavaScript compilers and start to tune out, stay with me. For our purposes, all you really need to know is an AST is a tree structure, an object, that describes your code. You've seen something very similar to this before, the DOM. The DOM is a representation of your HTML document that allows you to interact with it, and the AST produced by JS CodeShift is a representation of your JavaScript code that allows you to interact with it. I'm sure you've used jQuery to select and mutate parts of the DOM before, right? Well, using JS CodeShift, we can select and mutate parts of our AST. Make sense? Cool. So to recap, you parse some source code into AST, make some changes to it, convert it back to source, and save it. Easy enough. But every code mod I had seen or used previously modified code inline. It didn't move it between files. We needed to take the argument type checking logic from our components.js files and move them over to the template files. So here's the big question. How do we write a code mod to move logic between files? Thankfully, Robert is no stranger to code modding and had some ideas. First, rather than attempting to do everything in a single pass, we could break up the work into 3 separate transforms. The first transform would parse our component classes, get the type information from the argument decorators, and store it in a JSON object, which we could reference in the next transform. The second transform would use the JSON from the first transform to create and add Ember argument types helpers into each corresponding template file. And the third would go back to the component JavaScript files and remove all the argument decorators and their imports, which would no longer be needed. It seems so obvious in hindsight, but at the time my mind was blown. Everything started to seem much less daunting, and I could see a realistic path forward. Robert also introduced me to a tool called CodeMod CLI that would allow me to easily create, test, and run multiple JS CodeShift transforms from a single project. More on this later, but for now I had a plan, and it was time to execute it. First thing first, because I intended to open source the code mods, should I be successful in creating them, I had to examine the argument decorators library and determine every possible usage of it. I then recorded all these possibilities in input.js files, which I would use as inputs while writing the transform to ensure I covered every edge case. I also spent some time determining how I wanted to structure the JSON output and made corresponding map files that defined the expected output from running the transform on the input files. This is a pared down example of what those files look like. Next, I examined the Ember argument types library and did the same exercise. Only in this case, the input was a basic handlebars template file, and the output included prepended argtype helpers that performed the same logic that the argument decorators did previously. Finally, I wrote the input and output fixtures for the third transform, which simply removed any trace of argument decorators from the input.js file. I now had expected inputs and expected outputs for our component.js and template files, which I could use to start writing the transform logic. With this in mind, I started to write the first of the 3 transforms. The idea for this transform is to look at each property in the component class and determine if it has one or more decorators provided by the Ember decorators library. If it does, it parses the arguments of that decorator and stores the data in our JSON object. The JSON object stores the name of the file we're working with, the list of properties that have argument decorators, the decorator names, and the arguments that are passed to them. If you're wondering how or where do you actually write the logic, so was I. And fortunately, there are a couple of tools that are absolutely great for getting started, the most important being AST Explorer. AST Explorer gives you an environment to quickly experiment with JS CodeShift, among other things. Think Ember Twiddle for JS CodeShift. Here's how it works. The top left pane accepts source code. This is where you paste the code you wish to change. The top right pane shows an AST representation of the source code provided in the input pane. This code will change depending on which parser you use. JS CodeShift uses a parser called recast, so make sure you have the correct settings applied. The bottom left pane is where you can write your actual transform logic that will be run by JS CodeShift. And the bottom right pane is where you will see the result of running the transform on the input from the first pane. This is super helpful when writing traditional inline transforms because you can see the output update in real time. For our purposes, we're not actually transforming anything in our first transform, but instead generating a JSON object as a side effect. So the bottom right-hand pane isn't really useful in this case. Also, and unfortunately, AST Explorer currently doesn't support transforms dealing with decorators, so our usage is limited to the top 2 panes for this case. Still, this tool is useful for inspecting the parsed AST and determining how to select the nodes you need to use. Since I couldn't write the transform logic in AST Explorer, I needed to do it locally. For this, I used the CodeMod CLI to generate a new CodeMod project. The CLI provides bootstrapping, creation of text fixtures, out-of-the-box testing, and documentation creation. It's really a nice tool and takes care of many of the concerns you'll have while writing code mods. After creating the project, I used the CLI to generate the first transform, which creates a placeholder file for your logic and a couple example test fixtures, which I replaced with the input-output files I made before I started. Then, using the parsed AST pane from AST Explorer and referencing whatever docs I could find, I wrote the transform logic. I don't have time to go too deep into the details, but we can take a quick look at what the transform looks like. So let me explain what we're looking at here. The code in the top left of the slide represents the input pane from AST Explorer. By clicking on any part of this code, the parsed AST pane in AST Explorer would update to show me what I had selected. And the bottom left pane is the parsed AST pane from AST Explorer. By looking at this pane, I could determine how to select the relevant nodes using JS CodeShift methods. And finally, the right-hand pane is the JS CodeShift script I wrote in the project generated by CodeMod CLI. So let's walk through how I used these three resources to write the first transform. You might need to watch this section a couple times if this is all new to you. The first step was to select the nodes I wanted to work with. To start, I grabbed all the classes in the file, which is usually just the default export for Ember components. But other classes could exist, so I ran the logic on all of them. Next, I got a reference to the array of nodes in the body of the class, so I could filter them down to just the ones that were relevant for my purposes. I only wanted properties that had type information provided by the argument decorators library, so I started by filtering out any nodes that did not have decorators of any kind. And for the properties that did have decorators, I further filtered them down to ones that were call expressions and had a name of either type or argument. This ensured I was only working with properties with decorators provided by the argument decorators library. Now it was time to strip the relevant values from the AST and store them in a more portable format. For each node, I called a function, shown here as parseDecoratorArgs, that pulled out the relevant type values and stored them in a plain old JavaScript object assigned to a variable named parseDecorators. And last but not least, I stringified the parseDecorators object and wrote the result to a file that I could reference in the second transform. Once I had some logic written, my dev workflow was to run the transform using a test fixture as the input and manually verify the correct structure was being generated in the resulting JSON file that was saved to the root of the project. If it didn't work, I made some tweaks and tried again. Once I was satisfied that the transform worked against all my input fixtures, the next step was to run it on a single component from our app and verify the results. Then I did a directory that had 3 components. And finally, I ran it on the entire app. Of course, I did this many times as I tweaked the transform to cover edge cases and whatnot, but eventually I was left with a working transform that built a JSON object that described all of the argument decorators for each component in my app. I followed roughly the same process for the second transform. Only in this case, the transform would run on template files and use the JSON file from the first transform to determine how to update the template AST. We can use AST Explorer to work with handlebars files as well by changing the language select to handlebars. Set the transform setting to Ember template recast and you'll be able to experiment with writing your transform directly in AST Explorer. In my case, the goal wasn't to read or modify the existing code. It was to generate completely new handlebars helpers and prepend them to the input file. This was a little tricky at first because while I knew what the helpers should look like, I didn't know how to write the JS CodeShift code that would build them. Thankfully, there is a great tool called AST Builder that neatly solves this problem. AST Builder follows the now familiar 4-pane approach that AST Explorer uses. The top left input pane is where you enter the source code that you would like to generate AST for. In my case, this was the argument type helpers with various arguments. and the bottom left pane shows the JS CodeShift code needed to generate the AST that, when converted back to source, will generate the code provided in the input pane. The other panes show the input's AST representation and the expected output, but in this case, the left two panes are what we needed. Once I had the JS CodeShift code to construct the helpers, I could swap back over to AST Explorer and paste it into my transform code. The code here is super simplified, but hopefully it illustrates the idea. From here, it was a simple task of filling in blanks of the builder code with data pulled from the JSON file back in AST Explorer. After all the argtype helper AST had been created, I then prepended it to the template file's AST and returned the updated source. I verified that the transform worked as expected by looking at the output pane of AST Explorer. We can see here that the argtype helper has been added to the beginning of the file. Next, I used CodeMod CLI to generate another transform in my project and pasted the code from AST Explorer to the transform file. Since for this transform I was actually mutating the input file, I was able to take advantage of the built-in testing provided by CodeMod CLI. The provided tests take an input fixture, run your transform on it, and then compare the result to an output fixture. This made debugging any issues easy, and I didn't have to spend any time at all writing tests, which was awesome. The tests also verify that running the code mod multiple times won't cause issues, which is important. I made sure to write the transform in such a way that the files that had already been processed basically just no-opt when the transform was run on them a second time. This made it easy for me to gradually roll out the transform in my app, starting with one file, then a few, and eventually all of them, just as I had done before with the first step. Now with the second transform completed, the final step was to go back to the JS files and remove all the argument decorators that we no longer needed. This was definitely the easiest transform to write, since I already had the logic written to select the decorators from the first transform. Once I had selected the decorators I wanted to remove, I simply called a JS CodeShift method to remove the node. I also did some additional work to find the import statements and remove them as well. And finally, the updated AST was converted back to source and saved to the input file. Now that all three transforms are written and working, the next step was to actually run all of them in order on the components in our app to see if all the hard work had paid off. For this, I pushed my CodeMod CLI project to GitHub and used npx commands to run each one sequentially, though I could have run them locally as node scripts, but I wanted to make sure they worked when run in this manner since that's what other users would do. The result after running the transforms was that my app was about 98% of the way there. I had to clean up a couple components that were doing some weird things and were incompatible, but that took about 10 minutes. I could have spent a bunch of time trying to capture this edge case, but I felt I was at the point of diminishing returns. The code mod got me the vast majority of the way, and it was a more efficient use of time to do the remaining manual work manually. Once that was done, I built the app and, somewhat to my surprise, everything worked. In a single commit, I was able to update a huge amount of components from using an upgrade blocking pattern in library to a new and preferred solution that was Octane compatible. Almost immediately thereafter, we followed up with a commit to bump Ember to Ember 3.20 with Octane enabled. We could start to write Glimmer components and even template-only components and still have dynamic argument type checking. When I started this journey, I was pretty worried. My team was really happy with argument type checking and we didn't want to give it up. We simply couldn't live with a blocked upgrade path for Ember though. I started to feel like my past technical decisions may have led us to a dead end, despite being made for all the right reasons. In hindsight, though, I see it was because of this attention to craftsmanship that we were able to use code mods to get unblocked. Sure, there may not have been an off-the-shelf solution waiting for us, but with a reasonable amount of effort, I was able to get our app unblocked and moving forward, while maintaining all the benefits we had been enjoying for years. Looking back, I've learned a few things from this experience. First, your code doesn't have to be perfect to be useful. Keep in mind, code mods are meant to be run one time, so they don't need to be particularly performant, elegant, or even well tested. The code I wrote isn't great. It's not optimized, it's not bulletproof, but it did solve a disruptive and costly issue for my team, and if it worked for us, then it could work for someone else, so why not share it? Of course, don't set out to write cringy code, but you don't have to obsess over it and make it perfect. Don't be afraid to carve your own path, especially if it provides significant benefits to productivity. Even if you get stuck at some point and have to dig your own way out, the benefits are likely worth it in the long run. Keep in mind, though, that sometimes, rather than relying on the community to solve a problem for you, you need to take the reins and solve it for the community. You won't be alone. There are brilliant members of the Ember community who are willing to help should you ask for it, and there are excellent tools available to us. JS CodeShift is a little alien at first, but it's really not that difficult to pick up and get a basic transform working. Go try it. Keep the momentum going. Following this experience, I immediately created a CodeMod CLI project to hold code mods for my team, and wrote one to standardize some data attributes that had become inconsistent in our app. I'm now always on the lookout for opportunities to clean up tech debt and keep us moving forward. And finally, there are a lot of opportunities here to contribute to improving the tools around code mods. JS CodeShift needs guides and clear documentation. AST Explorer needs decorator support. AST Builder has some display and possible parsing issues. And maybe this cross-file approach could be better supported by CodeMod CLI. These tools are indispensable for working with code mods, but I think that due to the nature of code modding, get in, fix the issue, get out, and don't look back, they don't get the love they deserve. If you are looking for opportunities to give back to a broad community of users, look no further than these tools. I hope the strategies and techniques I've shared today help some of you keep your apps in good shape and upgradable, so they can continue to take advantage of the great things coming down the pipe from Ember. Thanks everyone, and stay safe.
Thank you to everyone for joining us for the first day of Virtual EmberConf 2021. I know I speak for all of us when I say thank you to all of the pre-conference speakers for sharing such inspiring talks. Don't forget to add any comments or questions you might have in the Discord server or the companion app. We have an exciting full day of content tomorrow, and I can't wait to see you all there. Bye.